you're putting this on a stream?
Oh yeah, everything I do is always streamed and recorded
So what do you
for.
do? Is that streamed on like YouTube or?
Yeah,
Yeah. Okay.
I just YouTube everything.
Okay. Well, I don't know how long I can do this for because my family is home. They're not feeling well. They're having a rest. So while they're doing that, I just got home with my son, and so while they're doing that, I can do this.
Okay, it's fine. I mean, for as long as you can, that'd be terrific. I really appreciate it.
Yeah. No.
Let me just share my. I'll just share the screen. Tell me if you can see it. Can you see my screen?
I can see watch stream. Do I have to click that or?
Yeah.
Is it like something else?
Yeah, you gotta click
Okay.
it.
Yeah, I got it.
All right. So this is a black hole formation analysis using a novel gravitational ether model. Anyway, so let's jump into the diagrams. So what we're going to do in this paper, we're going to convert. This is well, first we'll introduce the ether. So if this is some planet or star or a neutron star, then the ether is a fluid that flows into the star. It always flows in, and as it flows into the body of the star, it gets annihilated. So it's always consumed by masses. That's the theory, my theory of gravitational ether. This is the same ether from the old days. It also functions for quantum mechanics and for optics and electrodynamics. But for me, it's also quantum gravity. So if you put an apple here, an apple will just fall, will be accelerated because of this stream, this fluid flowing through the apple. And the apple will get dragged towards the star.
Okay, so this fluid is matter then, right?
Yes, and everything else is not. So I believe in quantum. Everything else is just waves. So an apple, right? The electron in the shell of the atom of the electron, that's a wave. That's a real physical wave of ether. It's waving around the nucleus. I am completely mechanical.
What are atomic nuclei in that model?
Atomic nuclei, a quark is a wave, a gluon is a wave, just like quantum field theory says. I am completely compliant with all of modern physics. I just add one layer under all of physics, the ether. Instead of the quantum space and the fabric of space, all these words, I just bite the bullet. I say, no, that's a fluid. It's a real fluid. It's called the ether. It was always called the ether. The wave theory of light is completely correct. And there is no particle wave duality. All particles are waves. Whenever they behave somewhat like particles, that's just because it's a wave packet. But it's still a wave. There are no particles in the ether except for the particles of the ether. The ether is a fluid, but everything else is waving. Okay. So that's the theory.
Okay, so you're
you know what? I can open up another paper.
Go ahead. It's hard to follow just because it's not something that makes sense. And I realize you've said you didn't like the lack of intuition you have about things that happen in quantum mechanics that have been tested and verified, which I can understand. A lot of them are weird. But at the same time, when you talk about this Aether, which is matter, annihilating when it reaches it's a neutron star in the diagram you showed, right? That's what the big circle in the middle represented. Is that correct?
Yes.
Okay. And so that neutron star, you say, is not made up of matter in a plasma state that's has such a huge gravitational force that it's taken matter that would otherwise be in a gas or liquid state. It has been compressed to the point it is in a plasma state, not solid, not liquid, not gas, but plasma. You're saying that plasma is actually just a bunch of waves and there's no matter in there. until the Aether, which is matter, enters it, and then it annihilates. And instead of annihilating with antimatter, what is it annihilating with?
No, 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 no. I mean, many things you said. I don't mean to say. So let me maybe let me first introduce to you my ether theory. So this is a separate paper about my ether theory because
This is different than the one you sent. Okay.
yes, this is different. I'll send you a link as well. Let me first give you a link.
Is this the
Oh,
one you were sharing around previously, or is this a different
yes,
one?
yes. There's
Okay.
currently very few papers. Yes.
This is the one that you've had the duck conversation with the duck traveling through.
No, the duck.
No, it's a different one. Okay.
Right here, these are the ready papers. So I have a paper about the second postulate. This is the duck. This is
Oh, okay. All right.
this is black hole formation, and this is the ether. There's two more papers that are also ready that I haven't so much shared until now. But the most
Okay.
important one, you first need to understand how ether is quantum gravity first. So let's maybe go through that. So this is the paper. So a new theory of everything. It's basically a theory of everything because it's quantum gravity and it fits all of modern physics. It doesn't contradict the rest of modern physics. Anyway, so the question is asked: why does the apple accelerate towards the ground? That's the question that everyone
Hmm.
that I'm asking. But I want a mechanical answer. I don't want stories about time and space. I want an answer. Why does it do it? So my answer is, so I'm looking for a mechanical answer. So the only mechanical answer I can come up with is there is this fluid ether that is always flowing towards the ground, and it's dragging the apple, and it's dragging every electron and every quark and every gluon and every photon. Everything is dragged along for the ride. So I did some calculations. At the surface of the Earth, this fluid is flowing into the Earth at 11 kilometers a second, which is the
Where
escape.
where did it come from?
The
This fluid.
calculation.
Yeah. So what you're saying from like
Where does
because
ether come from?
if
Or where,
ether is matter or ether, I don't care about the pronunciation so much.
sure.
If it's matter, and we see all matter being drawn towards Earth, and you're saying it's the cause of gravity as opposed to being affected by gravity itself. Is that correct? Am I following you so far?
Correct.
So what we call, like what I call gravity in the absence of Aether is I see it as um, fundamentally as large masses attract other masses, but the reason they do that is because they to be like extremely broad in general in my description, that they actually warp space time and cause things to be drawn to large masses by bending it. So
Yep.
larger the mass of matter, and everything, including what we consider to be waves or energy, are affected by that. And so you're saying this matter, which is not something we can detect, but it is matter. But it obviously isn't matter the same way other ones are. It's something that somehow exerts an effect on electrons and subatomic particles of the atomic nuclei and drags them towards the center of masses. But I'm still confused as to how we're ignoring the masses in this. If it's drawing them,
Well,
or does Aether not travel towards the center of the masses as well? Because like it does seem like in the absence of other effects, we still see, like in a vacuum chamber, for instance, we see objects falling at an equal acceleration towards our Earth, and that's something that we can replicate over and over again.
yes. Some of the ether is annihilated as it interacts with the apple. Some of it, so yes, some of the ether is annihilated. It gets swallowed up by the apple. therefore making the apple also a gravitational sink, but a tiny, tiny gravitational sink. Every atom, every electron in the ground that the ether interacts with, I mean, there's 10 diagrams that I want to go through that I'm going to explain. Basically, everything you asked is going to be explained as we go through these
Okay,
diagrams. So maybe we
that's
should,
fair. But
yeah.
that's the big thing I was having trouble with reading through the diagrams you sent before, and I did start out with the idea that because gravity is an acceleration, reaching a specific velocity to me suggests that the Aether must start out with a velocity of 0 at some point in space and time, which I agree. I agree that you have said, I don't agree that you're right about this, but I agree that you said that you don't want space and time to be part of the calculation. But many other people, myself included, are living our lives with space and time being embedded in one another. Like I can be at multiple places in space, but not all at the same time. And you know that sort of thing is something we experience. And the apple starts say at second 0 and falls towards the earth, and say it takes 10 seconds to do so from a certain height. The Aether to reach 11 kilometers per second must have started at 0 to be accelerated, or it somehow is affected by gravity in a different way on Earth than other matter. Is that like? Do you understand why I'm confused about that?
Yes. So everything is answered. Some of it in the other paper, there was calculations here. Here we assumed that the ether velocity starts at 0 at infinity. When r is infinite, we're starting the ether at 0. We're letting it accelerate towards the ground, and we're getting 11 kilometers a second from infinity. So, but
Why is it only? Why does it? What like? How does what causes a terminal velocity of Aether as it approaches from an infinite distance? We don't experience matter outside. Like we don't experience matter in a very high pressure manifestation outside of what we typically refer to as Earth's atmosphere and upper layers. We do recognize that there is some matter and energy up there, and maybe quite a bit of energy traveling through it, but it's a very large space. So at an infinite distance, the gravity exerted by Earth on this Aether from an infinite distance, what's causing it to stop at 11 kilometers per second and not get any faster than that?
I mean, this is just Newtonian gravity. I mean, I'm starting from Newtonian gravity. I'm just assuming that the universe is filled with a liquid or test particle. We're just placing. All we're doing in this. This is Newton. This is ma equals gmm over r squared. I mean, there is.
Okay.
This is just.
And r squared is that's our r is our distance. So infinity times infinity.
What?
Is
No.
that what that is? We're starting from infinity, or is that your radius from the center point, or is that something different?
That's 0. If 1 over
0.
infinity is, I mean, gm over infinity squared is 0. So the
Okay.
acceleration is infinitesimally small. It's not exactly 0, but it approaches 0 as we place the test particle farther and farther away. So we're placing a test particle at r equals infinite, and we're following Newtonian acceleration.
Making it very small, yeah.
We're following Newtonian acceleration.
If it's from an infinite distance, why can it not get infinitely large in velocity over an infinite period of time?
Why would it? Because I mean, that is what I mean.
Well, if it's infinity distance away from us when it starts, it would take an infinite amount of time for it to reach us.
Sure, but okay, but we're integrating.
And if we multiply that by it, we multiply that infinite amount of time.
Yeah, but we're
into it. I don't know how. Like, I just don't understand where 11 kilometers per second Why? How do you get that as the speed that it reached?
But
what is the limiting factor for that?
But this is just Newtonian. This is Newtonian gravity and Newtonian mechanics. This is F equals ma. This is F equal. You can. This is F equals ma, and we're setting it equal to gmm over r squared. So you could say that this is ma is equal to gmm, and you could say that F equals. Oh, sorry. Let's do F equals ma. This is F gravity is equal to, sorry, this is F acceleration, not F gravity. F acceleration is equal to F gravity, which is equal to this. This is we're just we're placing. Look, this is Newtonian mechanics with Newtonian gravity with differential calculus. So in differential calculus, we're allowed to integrate from infinity and see what happens, because every dr is basically zero. So we're integrating infinitesimal amounts in calculus. So we can integrate over infinite time, over infinite distance, and still get a finite amount. That's perfectly allowed in in calculus, in Newtonian calculus.
So you're using the gravitational constant, the mass of where we are in the universe, and the distance is infinity, because it's like, I just don't know how this thing's ever going to reach us.
I understand. Like you're saying, it's an infinite distance. So imagine
it's an infinite distance away, and I give it an infinite amount of time to arrive.
Then make it. Then
here, according to you, it's arrived already. It's here, right? We're like, except that we can't measure it.
No,
because we don't detect it.
No, it would. No. But the universe is finite. There is no infinities in reality. So, but this is just the math. So I don't care. Like, instead of infinity, you can put 1 trillion kilometers. You would still get basically this number. It doesn't matter. Like, when you put 1 trillion kilometers, the force of gravity would be infinitesimally small. It would be very, very small, but you would still get maybe 11.2, maybe 11.5, maybe 10.7. It doesn't matter. You'll get something around that. Like, the more you plug in, like infinity, the more you get close to some round number. Look, this is not even 11. I mean, 2gm over r. It's not 11. It's something else. Everything is rounded, so you don't have to imagine that it's actual infinite distance. You can imagine that it's 1 trillion kilometers or 1 trillion.
Okay.
It doesn't matter. Of course, it's some finite number. The ether, the universe, everything is finite in reality. Anyway, so this equation, this is just Newtonian. These are the equations that NASA and SpaceX uses when they do orbital mechanics and stuff. Like, when you drop something from infinity and you let it fall into Earth, then this is the equation. This is the this is the derivation. Yeah. This is just a derivation. So
I guess my biggest problem with my experience with testing gravity on Earth, which, like, to be fair, was over 3 decades ago. But I work with gravity every day at work when I'm not, and I'm affected by gravity constantly. But my experience was, I measured gravity to be an acceleration, not a velocity. And so it seems to me strange that this, you call it a liquid. I'm assuming, do you mean a fluid, or do you mean an actual, like, liquid state matter?
Yeah, it's a fluid. I mean a fluid.
A fluid, okay. Yeah, okay. I thought you might have just meant fluid, because it'd be very strange that we're not detecting a liquid, because a liquid would, I would think, most liquids, I would think, have a viscosity greater than any gas. But I'm no chemist, so maybe I'm wrong. So my my thought on this really, like, what I really got hung up on reading through this was not so much that that I had a problem with you using the calculus to come up with this number. It's just like, what is, if this Aether keeps going back towards infinity, and I agree, it could be just a tremendously large number, and there is some sort of a universe horizon we can't see past. I agree with that, and so it's indeterminate as to whether or not the universe stretches on forever. But with C, and the only thing that moves faster than C is the size of the universe, but we can't see anything that isn't within our view, and it has to be the energy that emanated originally has to start it out less than a certain amount of time ago, or we won't see it. And I understand that a lot of that stuff is nearly untestable, and so I understand that's difficult to deal with. But some of it can be put to the test, or we have the potential to put things to the test in the future, and we can only go on what we can observe right now. But when I drop something from multiple different heights, it continues to be measured to accelerate towards the ground. And you're saying that this Aether that starts at an infinite distance or a very, very large distance accelerates towards the Earth due to gravity. And no matter how far it accelerates from, it only reaches the level of something here.
No. It's not due to gravity. No.
Okay. And are you denying the existence of gravity, or you're using gravity to come up with a number?
I mean, you're asking a lot of questions, but you gotta let me answer.
Okay, go for it.
So, I am completely compliant with all of known physics. So you don't need to worry that I believe in some nonsense conspiracy, Earth center, Earth hollow, Earth not spinning. I don't know, Earth flat. I don't believe in any of those. So you don't have to worry about that. I'm completely compliant with Einstein, with Heisenberg, with Schrodinger, with every known, with the LHC, with the Higgs, with dark energy, with black holes. I'm completely compliant. So you don't have to worry about that.
Okay.
So now the ether does not fall due to gravity. The ether, when it flows, it drags things along, and that is what we call gravity. The ether flows, but not due to gravity. The ether flows due to a pressure gradient in the ether. So there are some places where there is high ether pressure, and there are some places where there's low ether pressure.
Gotcha. Okay, and the magnitude of the pressure is based on the size of the arrow, and
I don't know which. It could be depending. Let me see if I have a diagram with such. The inverse, the inverse, the inverse square law is actually due to yeah, I mean, it could be. It's a geometrical. I mean, it could be. We don't know what causes the right. Newton just calculated the inverse square law because he just took Kepler's law of equal areas and equal angles and equal times, and Kepler just took Tycho Brahe's data of where the planets are. So Newton derived the inverse square law just from Tycho Brahe's data on the location of planets. So Right. 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 So, but the inverse square law, if you assume that the Earth is a vacuum pump and the universe is filled with a fluid, an incompressible fluid, and the Earth was a vacuum pump that vacuums out this fluid from the universe, then you would get the inverse square law. That the closer you are to this pump, the faster this fluid is moving. And the further away from the pump, the slower the fluid is moving. And the ratio is the inverse square of the distance. So when you're very, very, very close to the pump, you're tending to infinity. You're getting infinite velocity. At the very, like, if this pump is infinitesimally small, and then it's basically a black hole. Then you have infinite, but that's not realistic. We don't care. But the point is that I'm just
In the world I work in, I can compress pneumatic fluids, but I can't compress hydraulic fluids. And at least not in appreciable amounts. I realize there is some compression, but it mostly pushes against other things. And in the conditions that we work at, typically from like say about minus 40 Celsius to about plus 35 Celsius, that's what I experience with the liquids and gases that I work with every day at work. So I realize, and I'm sure you realize too, that some things behave much differently when in different systems that are at different temperatures and pressures have different reactions to things, right?
so
So this Aether is a clear, colorless, incompressible, but gaseous type fluid that has not detectable except the way it drags matter and energy towards the center of mass of our Earth.
you know what? Can you join my StreamYard because I'm just unable to share anything through Discord. Discord is, I don't know
Well,
what.
I am seeing like this.
Yes, on
I'm seeing
Discord.
blue light,
Yeah,
right?
but
On
uh,
Discord is that
yeah, but I'm unable to share my screen. My Discord screen is not shared onto my YouTube. Like Discord,
okay.
the stream, unless
I see.
you,
So what you're sharing
you
with
know what,
me
you know
isn't
what.
there.
Okay, so you share. Why don't you share? You share the the paper.
Is that this thing here
The
that you've
last,
got up?
yeah, the last one. A
Yeah.
new theory of everything. You share a new theory of everything
Okay.
because
Direct messages. Join. I've got the only one you sent me is.
no,
This
not
isn't
you.
okay.
So on the side
Oh.
chat, you see on the side chat of this VC, there's a
Wait, are
side.
you on this? Should I go to the YouTube thing? Is that where I need to go?
No, no, no.
Okay.
First, um, I
Join
I
video.
sent you, but I'll send you another link.
Okay.
Uh, Let me send you another link. Share, copy. So I'll send you a personal link to you.
So I should be looking in my.
Yeah, personal
Well, I see the
DM.
history of everything. I have it
Right.
now.
So
Okay.
open that
Um,
and share that on Discord.
Okay. Can I do that? Okay. Okay, if I make this smaller, and then so start an activity, share your screen.
Yeah.
But I want
Share.
to share this one, right?
Yeah.
And I think that's fine. This is go live like this.
Very
Is that
good.
working?
Yeah.
You don't have to rejoin your voice that you
No,
invited
it's
me.
good.
Right?
It's good. It's good. It's
Okay,
good. It's
okay.
good.
This is good. Okay,
Yes.
the stream has ended. Okay,
You can
so this one here.
click on the left. There's an arrow on the left. You can click it to close the document tabs. It's just it's wasting space. You see on the left document
I'm
tabs.
looking for.
There's an arrow on the left under where it says file, like under the menu.
I
Yes,
see that.
click.
This, right?
Yeah,
Yeah, yeah.
yeah.
Okay. This is what you
Very
want me to have
good.
up,
Very
right?
good.
Okay, yeah.
Yes, yes.
So you can still hear me when I'm manipulating this. Okay,
Yes.
so this is the screen you had up when I was when we stopped the other stream.
Yes, that's very
Okay.
good.
So
Anyway, I'll talk, and you can continue asking questions. Feel free to
sure.
continue, because I only care that you understand, and once you understand, I only care for you to cross-examine my theory. That's all I want.
Fair enough.
Yeah. So we see the ether. For now, let's just assume, because I will explain in the following slides, but for now, we can just assume that there is a fluid that fills the universe and it flows into the earth. Later, we'll see more details that it flows into everything. For now, it's good enough that we just know that the ether flows into the earth. It's a fluid and it just drags the apple along for the ride. And that is the mechanical cause of apples and donkeys and everything to fall towards the ground. Everything falls towards the ground, including you right now. You feel that you're sucked into the ground because there is a fluid flowing through you at 11 kilometers an hour, and it's dragging you towards the ground, and anything you pick up and let go, it's getting dragged down. Everything is getting dragged down at the same rate. Doesn't matter if it's a small thing or a big thing, because at the end of the day, it's like a river. So there's no reason for anything in the river to flow at different rates. Whatever you put in a flowing river, it 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 it's not exactly like a river. It's a little bit different. But anyway, everything is impacted the same way, and that is gravity. That obeys whatever it is. It obeys Newton's law of gravity, universal gravitation. Do you have any questions? That's a mechanical. Go ahead.
I do.
Yes.
I do have questions. And
Okay.
so the first question that came up to me when you said this, and I realized I could probably almost answer my own question. So if I were to say I had something like a fish tank, but it was really large, and I built this and emptied it and made like a vacuum chamber. So I removed all the matter from it, and it had thick glass walls, so we could see what was going on inside of it. And let's say that I'm just gonna, rather than like have someone be in some special suit or whatever, I'm gonna say that we have a number of robotically controlled arms that we can use to drop things and see how they work. Is it your assertion that there is no amount of sealant, no thickness of wall I can put up, because this flows into the earth? So the entire thickness of the earth cannot stop this aether, which you claim has the properties of matter. It's not stopped. Like oxygen, for instance, is mostly stopped. There is some interaction of gases at the surface of the earth, but oxygen that's in our atmosphere does not typically penetrate very far into the soil and does not generally mix with the core of the Earth. But this aether, you're saying, would flow all the way through into the center of the Earth, and that the physical boundary that other gases and fluids are limited by, aether is not limited by those. Is that correct?
Correct. So everything you know and love, those are just waves in the ether. You could view the apple as tiny waves waving upstream, waving up. As the ether flows down, these waves are waving up. So the apple is waving through the ether. The electron inside, every electron inside every atom in the apple, every electron is a wave, a physical wave in the ether. The ether flows through it. The ether is like a river, and every electron in the apple is a tiny wave in this ether. It's waving in this ether, in this fluid. Every particle, every photon, every quark, every gluon, every elementary particle is just some sort of a wave in this fluid. Everything is a wave in this physical fluid. There is nothing that we know, like in the universe. There's galaxies. You look and you see galaxies. The galaxies, those are just waves in the ether. What you don't see, the blackness in the universe in a telescope, that's the ether. The galaxies and the stars that you see, those are composed of elementary particles, which are just tiny waves in the ether. And these waves obey quantum field theory. So quantum field theory says that every elementary particle is just a wave. So this is completely compliant with quantum field theory. I'm not.
Well, I have some. I still have questions.
Sure.
But the first thought I have, and granted, it's a pretty elementary and rudimentary thought, but it seems at first glance, and this isn't the first time I've looked at. It might be the first time I've looked at this particular image, but the ones in your other sort of set of diagrams that you sent over, I think there were some slightly different images, but they all sort of get at the same concept. And what it seems like is that the actions we see done by what we refer to as gravity are being replaced with a label of ether in your description. And because gravity can act through a vacuum, gravity can act through the matter that composes our planet, and it does exert an effect that looks a lot like what you're describing here. And so what ends up happening in my mind is I say, well, you've attributed unobserved attributes to this, and then decided to call what I call gravity, you're calling ether.
No.
That's the way this reads to me.
No.
But and if that's not right, then that's fine. But gravity is a thing that can do the things you're saying, and relabeling it doesn't seem to be helpful to the conversation. But if that's not what's going on, I'm all ears for why that's not the case.
No, I'm asking, if you scroll up, I'm asking what causes gravity. This question,
why does the apple fall?
Yeah, that's another word. In other words, what causes gravity? I'm not renaming gravity. I'm asking one layer underneath gravity. Assuming there is gravity, assuming apples fall and things fall and planets orbit and galaxies spin and the universe, assuming we know gravity, assuming Newtonian gravity, assuming general relativity's gravity. But the question is, what is the mechanical cause? What is the quantum mechanical cause of gravity? At the quantum scale, what is causing gravity? When you have an electron, why is an electron, right? The apple is composed of tiny electrons and other elementary particles. Each electron
Hmm.
is being dragged towards the Earth right now. Why? What's the
Okay, well, we know we know
Mhm.
what happens in this
Yes,
case.
but we don't
We know,
know,
and
but not
we
the
know through
cause.
testing.
Yes,
We know through testing
but
that
not, but not the
mass
cause.
makes other mass come
Yes,
towards it.
but
We
we
do
don't
know
know
that that's a
why.
fact, and
Yes,
we
we do.
know it's not, and we
Yes,
know, and we can isolate it away from electromagnetics, which
yes,
also can cause
yes,
similar looking things that are
yes,
different, and so we know that polarity can change attraction and repulsion and stuff like that at
yes,
certain
yes. But
distances, right?
yes,
So
but what
when
causes?
you ask what causes gravity to be a thing,
Yes, what is the
if
quantum
you hadn't
mechanical?
if
I'm looking for a quantum mechanical explanation for gravity. In quantum mechanics, maybe I should start from what we know.
well, in quantum mechanics, we just have a lot of different really small pieces of stuff
Yes,
that do stuff with one another that we can measure, see, and detect
in quantum
to
mechanics,
to a
in
but
in
why are you adding like if we add ether to this, and then I say, why does ether do this? Do you have an answer for why ether does it?
what do you mean?
Well,
What
we
does
know
what?
that we know we can test and measure
Wait, does what?
quantum mechanical
Does
effects.
wait, does what?
Ether, well, what you're claiming that ether is a fluid, a mysterious fluid at that. To me, so far, it's mysterious where it comes from and why it's there and why we can't detect it, because we can detect gravity.
Everything will be explained. There's
Okay,
basically a slide and a paper for all your questions.
okay,
Everything can be and will be explained.
that's fair. I'm not saying that everything about gravity is a total non-mystery, because some aspects of everything in the universe remain somewhat of a mystery, and some things may never get solved. I just don't understand why we're adding the ether concept when the ether concept seems to have been, in many ways, disproven or removed as a necessity for explaining the effects that we see. And if it did exist, there'd be other problems,
Hmm.
right?
So
So like,
I'm
to me
here.
this becomes a very difficult thing to understand, but we can keep going through it for a bit. And what do I have the right diagram up? It's this one that we should be looking at still, or should we be going down?
Let's go one by one. So this was the question: why does an apple fall? Let's go to the next
Hmm.
one.
Okay.
Scroll to the next one. Good.
Yep.
This is the answer. So the ether is a fluid that, for some reason, we'll get to exactly what the reason is. For some reason, it
Hmm.
flows from outer space into the center of the Earth, and as it
Okay.
crosses through, as it goes into the ground, it drags everything along for the ride, including the apple, including us, including the tree, including the air, and that gives rise to gravity. Okay,
Okay.
let's go to the next slide.
That's this one here, right?
Yeah.
Okay.
And the same question. This is the Earth and the Moon. At the top is the Moon. At the bottom is the Earth. It's the same
Yep.
question. Why does the Moon fall, accelerate towards the Earth? Let's go to the next slide. That's just a question.
And basically, this could just be the apple. It's just a
Yes.
larger piece of matter further away. Yeah.
Yes.
Okay.
Yes. So here we see the answer. The ether flows from the universe mysteriously, as you said, into the earth. It goes through the moon, therefore dragging the moon for the ride. And that is what causes the moon to be attracted towards the earth.
Yes.
Okay. Sounds fair.
So
Mhm.
I don't agree that you've proven this exists, but I agree you're asserting it.
Yes.
Okay, so the Earth, Moon, the
It's
Earth.
all I'm
Number
saying
three.
is
This is okay. The blue arrows represent the flow of the
yes.
ether, and I guess I could draw an infinite number of these arrows, because it's going in. It's coming from, and like the Earth is represented by a disk here, but that's a cross section. So if I had a globe, I would see it coming from literally an infinite number of directions from outside the universe,
Yes.
right?
Yes.
Okay,
You can imagine Earth is a vacuum pump, and it's vacuuming this fluid out of the universe, and mysteriously the universe is magically refilled with this fluid and it keeps flowing into the earth. And
Okay.
as it flows into the earth, it sucks in you, me, apples, and moons. Let's con-
Okay, that's fair. And you're in these diagrams, you're not dealing with like the inertia that keeps these things orbiting, but you're going to get to that, right?
I mean, what do you mean the inner? I mean, it has nothing to
Like the
do.
moon, the reason why the moon doesn't fall into the earth is because it has an initial movement that is
Correct.
going
Okay.
somewhere else. And so
So
it keeps falling towards the earth, but it also is going where it's going.
yes,
And so it's drawn towards the earth without ever falling into it.
right.
At least not for a long time.
The flow of the ether is towards the earth. So the
Yes.
moon, whatever inertia it had to go, let's say, in a straight line to the left, it's gonna keep doing that as it is sucked in. I mean, it's getting a centripetal acceleration towards the Earth, and that becomes the orbit. Yeah, I should.
Yeah, and
Mhm.
there must be a larger amount of this ether acting on the sun earth or sorry the moon earth system around the sun as
Yes,
well, along with the other
yes,
bodies. And
yes,
so you could relabel number
yes,
2 could be the sun,
yes,
number 1 could be the earth and moon together,
yes,
and the same thing is happening there. And
yes,
they have their own inertia that keeps them in orbit as
yes,
do the other planets.
yes.
Okay. And so okay, I'm still hung up on it seeming a lot like a relabeling of gravity, but is that everything we need to see from figure 4? There's more figures, right?
Yeah, yeah. We have like five more figures. Yeah. All
Okay,
right, let's
that's
go.
that's fine.
Hmm.
That's fine. So okay, so this looks a lot like what gravity does if you leave out the orbital mechanics of it, but this is like something holds
This
these
gives you
massive bodies in
this
each
gi-
other's proximity,
this
right?
gives
Like
you
that's what you're getting at.
this gives you orbital mechanics. This is already orbital mechanics.
Yeah. Except that this shows just the drawing of the massive bodies centers towards each other. It doesn't show the other movement, but that's fair. That's fair. It can be a more simple diagram than that. I'm cool with
Yeah,
that.
I can add more diagrams. You're right. Yeah, this could be more interesting. Sure.
Okay, and this ovoid here is a galaxy, you say
Yes.
here.
Same
This
story.
galaxy is spinning.
Yes.
What is holding the galaxy from falling apart?
Yes.
4, the answer is gravity, but what is causing gravity? And 6, this is the aether flowing into the galaxy causing gravity. And I think we are relatively recently in the history of mankind discovering that many galaxies, maybe all of them, have a super massive black hole at the center. And I say many because I don't know that we've examined every galaxy in the universe, and I don't know that we ever will.
Some of them
Um,
we know, some of them don't. And
yeah.
there is
Okay.
also
So
dark matter. I'm
go
I'm
ahead.
ignoring dark matter, and some galaxies don't have dark matter. I mean, but right now, all I'm saying is, in general, all galaxies experience this fluid flow, the ether flow, and it
Mhm.
is at least part of what's holding them together. We know there's dark matter. That's also we don't. I don't know what that is. I don't. I'm not.
I don't think anyone knows exactly what it is. We see effects that look like they come from
Yes.
masses, right?
Yeah, we
And
don't
they
know.
they act they act like large masses. The
Yes.
the effects of large masses are seen without seeing the physical object that might create them, and that is another mysterious thing,
Yeah,
which is
I
fair
have
enough.
nothing for now. I'm saying nothing about dark. I don't have a position on dark matter.
That's fine. I don't have a definitive one. I don't believe modern science has come to a definitive answer on it either.
Yeah.
We just know that we detect the effects of something that
We
meshes with this to
I
some
don't
degree.
know. I didn't look into it. I honestly don't have a position. I need to look into it. So until then, I don't have a position at all. I mean,
Okay.
I know what you know, what I see on YouTube. All right, the
Yeah,
next. Now this is the universe. This is the total universe with a bunch of galaxies, and each galaxy has ether flow into it. And the question in red, I'm asking, well, if there's ether flowing into all the galaxies, then the universe should fairly quickly run out of this fluid because it's being annihilated as it's flowing into massive bodies. So the universe should shrink and shrivel back into oblivion. Yet we don't see that. So what's going on? That's the question in the
Mm.
red.
Yeah, and I'm sure as you go on, you'll deal with the fact that I think we've figured out that space itself, the size of the universe, is expanding, and and and
Yes.
that and that we have thought about whether there could be like big bounces, like where there's like a
But
cyclic
before but before we
universe in and out, big crunch,
but
etc.
bef-
But I think they've ruled that out for now.
but before we talk about
So,
bounces, the point is my theory predicts dark energy. So let's go to the next slide.
okay, that's fine. So the universe, and this is a point that you are going to explain as we go, right? That
That's
why we never run out of this Aether,
yes. And the answer,
because it's you're suggesting that it's a finite amount of matter.
yes. Yes. And
Okay,
here's the
very good.
answer. So the answer is dark energy. So we all know that dark energy is a mysterious force that is pushing galaxies apart and is blowing up the universe. Well, according to my theory, with this is just the creation of more ether. So ether seems to be spontaneously maintaining a constant pressure. So ether is always creating more ether in order to maintain a constant positive pressure across the universe. And that is the cause of the expansion of the universe. That is the cause of the redshift between galaxies. So my
Mhm.
theory predicts the existence of dark energy, or my theory needs dark energy. My theory cannot survive without dark energy. So already we see an advantage of my theory over modern physics. Modern physics never predicted dark energy. My theory would have, if I didn't know about it, I would have had to predict it because the universe should have shriveled out of existence because my ether flows and gets annihilated as it flows into every massive body. So my theory gives us first
Okay.
prediction. It necessitates dark energy, and now also we understand why dark energy must cause the universe to expand. It's because I need dark energy. In the next slide we'll understand why. I need dark energy to maintain a constant pressure. It's not enough to refill the universe. That would not have been enough. I need dark energy to maintain a constant positive pressure all over the
Yeah,
universe.
but this is something like, if we're gonna go back to your pump analogy, and maybe we should look at we instead of thinking about gravity pulling things towards each other, we should think about something like you're suggesting something where you're coming up with something material
Yes,
out of mystery box,
yes,
okay, and you're pumping it out into the universe in order to fuel the continual expansion, not just of the distance between massive bodies, but you're literally like dragging them apart from one another with Aether instead of like. And I think this is at the leading edge of scientific inquiry at this point. I think there's some pretty good measurements to show that the distance between things is increasing at a rate and at a speed which suggests that space-time itself is getting larger, and that's my understanding of it.
yes,
Now, to be fair, I am a heavy haul truck driver, not a cosmologist, so my knowledge of it is relatively rudimentary. But the suggestion is that space-time itself is actually getting larger and larger. And when it comes to dark matter and dark energy, and I realize you're addressing dark energy, and dark
yes,
matter and dark energy are not the same thing. They share a name,
yes,
apart in part, but they're not the same thing, and they may not really be related other than being parts of the universe. And they are hypotheticals to
yes,
what we know about the universe. And the reason the reason that they're hypotheticals is because we see more stuff happening
Yes.
in the universe. There's more movement,
Yes.
and there's more movement than we see matter for, and there's
Yes.
more movement than we see energy for. But the fact that we can't actually like witness something and see it does not negate its existence, which is why I'm not saying this ether idea is nonsense just because I can't see it. But it seems like you're adding something extra to it, especially the part where you're pulling it out of some mysterious place. But so again, instead of renaming gravity, are you now saying that dark energy is a replacement for ether in this? Like this is where the nomenclature swap comes in, or is that not the case?
No, there's never nomenclature swap, basically, except for
Okay.
my ether needs dark energy. My ether needs something to maintain a constant pressure of ether, because my ether gets annihilated, and very quickly the universe should have run out of ether and should have shriveled and collapsed into nothing. So, since we know the universe has not collapsed, the universe exists, therefore, my ether theory would have predicted, if we didn't know, it would have predicted dark energy. Namely, something is creating a constant positive pressure of ether all over the universe. And this constant positive pressure is blowing up the universe everywhere at the same rate. So it's causing the distance between galaxies to grow linearly with respect to each other, with all the effects. So I am completely compliant with dark energy, but I am completely predicting, and I need my ether theory absolutely cannot exist without dark energy. Now, dark energy in cosmology, modern cosmology today, is superfluous. No one knows why it's there. No one could have predicted it. But my theory needs it and would have predicted it. So this is
Okay,
one.
are you saying that there's no current hypotheses in in modern cosmology that are working on dark energy? Because like I'm under the impression people are looking at this, and without your ether hypothesis being involved. But what your understanding that that dark energy is superfluous to all other modern cosmology?
As far as I know, you could have predicted dark energy as a force to stop the universe from collapsing, according to Einstein. According to my model,
Okay.
that's impossible. You need to maintain a positive pressure for my ether to work. That positive pressure must cause the universe to expand, to accelerate its expansion, and for redshift. So, according to
Okay, but
Einstein, go ahead.
okay. Well, see, when I think about it, like because you've described this ether as having as being a fluid, not and you clarified you didn't mean because you had inadvertently called it a liquid, but you meant a fluid. And so this thing is something that flows. It has to have in your model a non-finite um, origin because you have to keep providing more and
Yes.
more of it to keep pushing things
Yes.
out, right?
Yes.
And your description of it is something that flows through matter, but in doing so bonds with all of the electrons and all of the components of the nuclei. In doing this bonding, it then drags matter away from its origin point, which I'm assuming is at some central point in the universe. But that's not 100% clear. But by looking at
So,
this
not
diagram, it
exactly.
looks like everything's moving
Not
away from a
exactly.
center point. That may
No,
not be the case.
not exactly. So it doesn't bond with matter. It annihilates upon any interaction with any massive object. When it
Okay.
interacts with anything that has mass, it instantaneously annihilates. Not
Okay, but
completely.
it annihilates itself.
Yes,
Not it's not like antimatter where the two
correct.
meet each other and explode into nothingness
Correct.
or
It
implode into nothingness, right?
correct. It just
This
it
is something
it just
this is something
annihilates.
where
Yeah, the ether.
it
Yes.
disappears on its own due
Yes.
to what I'm going to call for now a magical property that it possesses.
Yes. Yes. You could.
Because most physicists agree with the concept that's part of modern physical theory that seems to have us seeing ourselves as having um, no matter or energy being created or destroyed, but they can change states, right?
Well, not exactly. We know there is dark energy, which is created out of nothing. So we know there is no conservation of energy in a cosmological scale. On cosmological scale, there is no conservation of energy. So I wouldn't
Okay.
be. So I'm not the first one to offer that there is no conservation of ether. So ether spontaneously self replicates to create a constant pressure throughout the universe and self annihilates upon any interaction with any massive elementary particle.
So it does seem like a pretty magical thing when you compare it with other parts of physics, like where energy and matter as we know it, as we've interacted with it, as we observe it using spectroscopy and the like, where we're able to identify the composition of matter that's at far distances from us.
No,
All of
no,
all of that,
no, no, no. We know there's dark energy, so we
all of
know.
that, right? And all the observations we make don't find this ether, but this ether it self-replicates and self-annihilates. It doesn't need it's like matter and behaves as matter. It bonds temporarily with matter just enough to drag it along, but it doesn't stay bonded to it, and it disappears into nothingness to a certain degree as it interacts with objects that have mass, which is everything in the universe that isn't currently energy. And so I do find it really a strange idea to put out as a postulate, but I do understand that you've come up with this and you've written it down, and I'm entertaining it for the purposes of trying to understand what it is you're saying. And so I'm not sure how you would prove this, but I guess there's a couple more slides to go through.
Yeah.
But I understand what you're saying is that you have decided, I think unilaterally, I don't know if anyone else has helped you confirm this, because I believe dark energy is still an unknown. But you're suggesting that your hypothesis would use the dark energy that's been detected. The effects of it have been detected, and your theory,
My theory
your
needs.
hypothesis that you're trying to get this ether theory built upon,
Look,
right? If we're going to
Einstein.
use this
Look,
term carefully.
look. If you think about the universe, right? The universe, you agree that it has to collapse into itself. Either with me, with ether, or without ether, it doesn't make
Don't
a
I
difference.
don't actually I don't actually agree with that. I think other things, like there's a heat death of the universe where it just spreads out to the point where there's no longer
Hold on,
anything
one
interacting
second.
with anything.
Okay, you
I
know what?
think that's a possibility too, and that's one that's been put
Okay,
forward and makes some sense.
okay, okay. Wait, it doesn't matter. I want to just go through the paper because we can have many discussions, very fruitful discussions. But for now, I want you to see all the diagrams. I think it will help you understand the power of this new theory. So we finished this. This is dark energy. It's pretty
Mm-hmm.
good. Okay, let's go to the next
Okay.
slide.
Okay. So this next one. So I started sliding to it before we talked about
Okay,
saying that we're done there. Okay. So is the electron is like the shell of the electron is the blue circle, or are you pointing at the yellow thing? Not that it necessarily matters. Or this is the annihilation. Okay.
yes. So
Okay.
what
So an electron is the blue circle represents, and a physical electron, not the area in which it may likely exist.
Yeah, I don't believe. Uh, so I depart from quantum mechanical interpretations. For me, the electron is not some probability wave; it's an actual wave. But in this case, I'm showing the electron as a sphere, but it doesn't matter. It doesn't
Okay,
matter right
so
now.
and there's two number one. So the one is a label, and then for this the ether always flows into massive particles, bodies, planets, and galaxies. But where does it go? But so it flows into anything that isn't energy, or do you mean it has to have like a certain amount of mass? Because electrons have very small, tiny mass, but they're not massless.
I think, yeah, electrons are not that tiny. I mean, there's tinier, much tinier particles.
Yeah, yeah, there are. So
It's like
so
medium size, medium mass. So here's finally we see the quantum mechanical impact of the ether. So the ether I
it's
just drew
flowing into the electron. Okay.
right. So as
And
it
then the yellow, okay, so you like so is it following the numbering? So the first thing is this is an electron. Is flows the ether flows into the electron. And then number 3, the ether self-annihilates upon interacting with the electron, not before endowing the electron with mass. The ether has the Higgs mechanism built in. The ether is the quantum field. And so this annihilation doesn't cause any sort of change to anything, except that you're saying the electron had no mass
yes. This
prior to
is
interacting with the
this
ether.
right. This is the Higgs. The Higgs theory is that all particles, all elementary particles are massless before interacting with the Higgs mechanism. The Higgs mechanism basically causes them to bounce back and forth within the cause them to bounce back and forth. So as an electron, let's say, is moving forward, it's not really moving forward, it's bouncing, it's vibrating, and as it's vibrating it's moving forward, but it's vibrating at the speed of light. Altogether, the speed of an electron is always the speed of light. The speed of all elementary particles is always the speed of light. It's just that because of the Higgs interaction, they sometimes look like they slow down. They don't really slow down, they just vibrate. So the more massive they are, they just vibrate more, and this vibration takes up more and more of the total velocity. But the total velocity of any elementary particle is the speed of light. The more it vibrates, the slower it appears to us, and the more massive it appears to us. A vibrating photon appears to be massive. So these are just so all this is the Higgs theory. This is not me, this is Higgs. So this is what Peter Higgs came up
Okay,
with.
well, okay, so and Higgs is a pretty major figure in quantum mechanics,
Yes.
and has the Higgs boson is named after them because it's what they predicted and it was found.
Yes.
So okay. But we're not talking about the Higgs boson here. We're talking about the Higgs mechanism, is what you're saying
Yes.
here, right?
Yes. As far
Okay,
as I know,
so this is this idea that what you've just described. I'm saying this back to you to make sure we're on the same page. Is that you're saying that no piece of matter has any inherent mass until it interacts with this somewhat mysterious
right, but
medium that you've
look,
suggested exists.
but
It's
I'm
ether.
all I'm
But
doing is
other
all I'm doing is I'm taking known physics and I'm just saying, okay, quantum field theory, that word field, just replace it with ether. You could say that
Okay,
that is.
what is a quantum field in your mind? Because I have a definition that I've had explained to me by a quantum physicist, but I'd like to know what your definition is because I think it would make sense for us to be on the same page with what a quantum field is.
So to me, there is no field. That's not nonsense. To me, there is ether. I don't believe in fields. I believe in
Okay.
in this paper. I don't think the word field shows up. If I ever say the word field, delete it and replace it with ether, because
Okay.
I believe in a mechanical universe, not a mathematical, nonsensical, literally nonsensical, meaning making no sense universe. My universe makes perfect sense. It's not
I don't know that it does.
to me.
And the reason why I don't know that it does is
Then ask
because
me
you're
questions.
suggesting, yeah, you are asking, and asking questions is fair, quite reasonable. And these questions may be something we can look into. I don't mean me, because I'm going to continue trucking until I have enough money to go to school, and I won't be studying this. I'll be studying something else, and I may interact with it at some point. Um, but my intention is to study um, a different part of physics. But what I'm having trouble with here,
Hmm.
and I don't know if other people are having trouble with it, but I'm having trouble with it, and I'm gonna have to wrap this up because my wife has woken up and she's not feeling well, and I'm gonna have to go help her.
Hmm.
So I'm too loud, and I'm a very loud person, just in and of myself. But how many more figures have we got here? Because I just want to see, there's
We
one
we can
there's one more. Okay,
continue.
I'm gonna try to wrap.
We can
We could
continue.
have like a part. We could have a part two of this. Yes, and I was gonna say that, like, I I would also think that it would probably do me some good to just double check on a couple of these things, to um because a lot of these things that you've mentioned, I've heard of, I've read about, I've talked about with people. They don't know a lot about them. But when it comes to quantum fields, my understanding is a quantum field is just an area with a non-zero value, and that's a very basic definition of it.
To me,
But what we have,
that's meaningless to me. I
well,
I demand.
it
Here is my demand. I demand whenever somebody talks to me, I demand that I should be able to understand whatever they're saying. If what they're saying I cannot understand, maybe I cannot understand after the first, second, third, fourth, 10th, at the 100th attempt of me trying to understand something, I have to just say you're lying. And I've
okay.
heard this nonsense about fields probably 1,000 times, if not more. So at this
Okay, so
point, it's just a
so are you
lie.
saying that, okay, but okay? If I take an area of the universe, any given area, and
You mean
draw
a
a
volume?
box around it or a ball, I take any volume
Yeah.
of the universe. Okay,
Yes.
even if I take an aquarium in front of me, let's
Yeah.
say let's have a 1 liter fishbowl in front of me,
Yes.
and it is full of nothing but one photon. I've somehow trapped one
Yes.
photon in there, and it's a vacuum. Okay,
Yes.
it's a
Yes.
vacuum tube. Let's pretend I have a perfect vacuum, and I've been able to insert one photon into it, and I've trapped it there.
Yes. With mirrors.
Okay,
Yes.
that this is a this is a one. It is one photon.
Well, sure.
Whatever the energy of there's one piece of energy in there. It has no matter inside of it. Okay,
Right. But a
that
photon.
in the inside of that,
But
that's a field with
but
a non-zero value,
that's nonsense.
and so
That's
it's
nonsense.
not
No.
nonsense.
It to me.
An
To
area
me.
of it
To
is an
me.
area with
To me. To me. That's
no
okay.
every
Here.
value.
No. No. To me, that's not. I'll tell you what I see. So what I see is a fluid, and the photon is a tiny wave, and it's waving around. And when it hits the side of the aquarium, there's a mirror, and it experiences something. I would have to think what exactly it is, but it
Yeah, well, you're
bounces.
talking about what it bounces as a reflection, but
It's a
if I could, I
wave.
just want to go back to my description of this field.
Hmm.
This photon I've trapped in there. Now I'm going to make the aquarium disappear. There's no fishbowl.
Are you
That
are
photon
you
still
drawing?
exists in
Are
that
you
space.
sharing?
No,
Are
I'm
you?
not drawing anything.
Oh, okay.
I'm not drawing anything. Use your imagination here.
Okay.
Photon exists in the universe. I trapped it. Now make the I make the trap disappear. That photon still exists, and it occupies the same region of space that I trapped it in.
Okay.
It is a piece of the universe with a non-zero value,
That doesn't
and
mean
that is what a
anything.
field is.
That's
That is what
nonsense.
a field
I
means.
reject.
It's a non-zero value.
I reject it. It doesn't mean anything to me. I'm sorry. I
No,
completely
but
I reject
it is
it.
still
It
definitional
doesn't mean
inertia.
I don't care.
Now,
I don't.
I
To me,
do have
it's
to go.
yeah, yeah,
I have to quiet down my house now.
yeah.
But I appreciate the conversation. I
Thank you.
appreciate
I
you inviting me to
appreciate your
have it.
time.
I'm always interested in people that are curious about what's going on in the universe, and I like to talk about it. So I
Fantastic.
appreciate it,
Thank you.
and hopefully we'll get another chance to do it. I'm
Yeah,
just going to close this
yeah.
and say goodbye. Thank you so much.
Thank you. Bye. Hey, wait. Okay, let's see messages from other people. So, Totoro, hey, what can I do for you? And Falcami, Spaghetti, Amber, and Fligagigu. Okay, no one. Do I want to talk to anyone? I don't know if I want to talk to anyone. That was a good discussion. So basically, usually when I talk to rooms of people, they basically have probably even less understanding than he does of what I'm talking about. So I'm wasting my time. Arguing with a room of people is a complete waste of time because each person needs a lot of attention. I need so much attention to explain slowly, 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 slowly. So it's a waste of time to debate rooms of people about ether. It's just a waste of time. And they get upset, and I get upset, and everybody gets upset. We're all wasting each other's time. So that's that. Having said that, let's see. Let's see what's going on this server. It's probably empty, I'm assuming. Yeah, the server is dead. The server has died. hmm Fascinating. Absolutely fascinating. But he gave me plenty of feedback that I would like. I mean, a lot of the stream was ruined because it's impossible. I don't know how to make, how to share Windows entire screen. I guess I could share the entire window. There's nothing I'm really afraid of sharing within this window. I don't have any other choice. I just don't see that I have any other choice. Let's this thing, let's close it. I don't need it. Let's close everything. I would like to resolve this issue once and for all. I just don't see how I'm ever able to do it. The problem is these are activities. This is video. Share your screen. Also share audio. And then you can share the entire screen, which I could do, which is very dangerous. And then I don't know what would happen. The entire window. So I'm going to share. Let's try this. Everything. So as I switch around and around, you see already nothing is shared here. This is blocked. Right, because I'm trying to share Discord. Let's see. Let's see if I can go to live. You see, it doesn't share. Your stream is still running. So we've paused this preview to save your resources. I don't want to save my resources. I honestly, I don't want to save save it for what? I don't know. I don't know. I mean, this is so bizarre. Right? This is shared. This is shared. There's no issue with this. I'm sharing Discord, but Discord, I told Discord to share, right? I- I'm I'm supposed to see other windows. Oh, now it is. So, and then it stops. It starts and stops. Uh-huh. That's a problem. So I can go here, it works. Then I go here, it stops. Here it works. It's working, it stops. So I don't know. Oh, now it's working again. Stops. Oh, it's probably gonna do like a recursive thing. Maybe if I remove this, I don't want to waste. I don't want to waste. I don't want to destroy this stream with nonsensical questions that I don't have answers for. Okay, it's not working, so stop the sharing. That's that. That's the end of that. Okay. So what I would do, like there's so many points he brought up, I don't even know where to begin. There's like so much I need to explain, but that's because he is a layman. He doesn't understand so much. I need to teach him like calculus. So I don't know if he is if it makes sense to use him as a test particle. I don't know. Let's see if I can talk to anybody else. Let's try with Chinas. He wants to eat first. Let's see what's going on. Okay, and Totoro, can I talk to you about my Aether? Totoro hates me. Hover. Let's see what's going on with that guy. She never answered. Spaghetti. Let's see. Spaghetti. Fligagigu. Let's see. Fligagigu. So I think we asked everyone, right? Phil. This. Did I ask Tapi? I think I asked everyone. Okay, Felkami, Fligagigu, Amber, Spaghetti, Hover, Totoro, Chinas, Mr. Trucker, Choking Hazard never answered, Weasel never answered, Mordwan never answered, Sean G never answered, Gamma never answered, Obscure never answered, Blutch. I've never spoken to her actually. Andrew. Who else? Luigi, Divine. Let's see what's going on with her. Why does it scroll automatically? That doesn't make any sense. Playing Slay the Spire. Truth prevails. Oh, what's going on with her? Who's that? Hover. Hover Givinci. Hover Givinci. All right. Me. How are you,
Hey,
Javier?
hey, what's up?
Hey, what's up? What do you want to talk
What
about?
happened? Nothing. I just thought you were on, so I just thought you'd be talking about
Okay.
stuff, and I would listen.
Do you want to talk
What
about
happened with the?
what?
Sure.
What happened with what? With the Al Trucker?
Yeah, yeah. I missed all of that because I got distracted by something else.
He had to go, but we'll continue. I mean, he's a good guy. He's not like he's not a hater.
Mm-hmm.
So what I was thinking is that I should try to avoid debating people on their platform in general.
Oh, 100%. You got to be in control as much as humanly possible, right?
Yeah, because you see that
They'll
like
shut you down and mute you.
right, you see that even on my server they attack me, and there's like you saw how Divine was like she was attack very forceful, very
Mm-hmm.
kind of terrible. So and she's like a baby. I don't know. She says she's a child, so she's probably I don't know what she is. Let's see.
I think
Not
she said
interested.
she's like 16 or something like that.
Yeah, I don't know. She said she's a child, so I don't know how old that is. Uh,
Yeah, people also lie about that stuff as well. People come on Discord and they're like, "I am blah 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 age," and then they're lying about it.
I'm fine. I don't care. It's fine. I mean, you can lie. I mean, what do I care? You can be whatever you
I'm
want.
500 years old.
Yes,
Yes,
yeah, you
I'm
can
trans temporal. Okay, I'm
dress them
older than
for.
yeah,
I'm older and younger than I am. Anyway,
exactly.
do you want to see? Do you wanna? Do you want to talk about Ether, or do you want to talk about news? Do you want to roam? Do you want to roam X? Do you want to roam what else? YouTube, or do you want to
Yeah,
talk
maybe
about
we can
something?
roam. I don't know about Roman X. I mean, my X feed is so cursed. It's just filled with like far right like nonsense and like this misogynist. Like I'm just like, what is happening? Like it's it's just like fresh and fit. Did you know women bad? I'm
Oh
like,
my
okay.
God,
But
fresh
did
and
did
fit.
women be bad though? Did you know women bad? Like,
Yeah,
the
but
Jews, the
but the,
Jews are bad. I'm like, okay,
yeah, but
you
they
know, bad to
invite.
worse. I'm like,
I mean, they invite OnlyFans chicks to their
yeah,
platform, and then they say OnlyFans chicks are bad, but you invite them. You're inviting these chicks, so
yeah.
like
And
you're not
obviously the viewers are like going to subscribe to their stuff, right? Like,
right. I mean, they're not inviting like some female doctor, dentist, CPA, lawyer,
yeah,
and like there's plenty of normal women,
yeah.
but
They've got like sampling bias. Yeah, exactly.
right, but normal chicks don't want to be on their show. Why would they? Why would a normal chick come to the show? But a chick that has an OnlyFans, that's for her, it's great. She makes more
Yeah, because
money.
she can promote it. Yeah, exactly. Yeah, yeah. And the
She
more controversial stuff she says, the more popular she'll be. You know what I mean? Like, the more,
yeah, she monetize right. Her. She monetizes her appearance on their show. So and they monetize. It's a win-win. So like they're just a mirror image of OnlyFans chicks. They're just a mirror image. They complete each other. And
Mhm.
as much as I guess they hate these chicks, but they love to hate them. And the chicks are the same. They also love to hate them. So they have
Yeah,
this love to hate each other, but they make each other exist. They bring each other into existence. Without each other, they would have less of an existence. But 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 they don't. I don't know if they see it anyway. Uh,
yeah. It's
so
like the
today,
whatever podcast.
so
Sorry, go on.
today, the Iranians tried to assassinate Benjamin Netanyahu with a
Oh, really?
drone. Yeah, a drone strike to his house.
Wow.
Yeah, I mean,
They're having more success with these drone strikes all of a sudden. I don't know what's going on.
no, these are very good drones. I mean, look,
Yeah.
the Iranians. The Iranians are. They're not dumb. They're not dumb people.
Hmm.
They're not. They're. I mean, they're not Arabs. They're not considered Arabs. They're actually considered.
They're Persian, aren't they?
They're Aryan. I mean, they are Aryan.
Oh.
They're called Iranian. They are Aryan. I mean, I think Hitler took the name Aryan from them, and he took
I think so. I heard that too. Yeah.
and he took the flag. Like he invented, I think he invented the Aryan from the Iranian. Where he created a mishmash, and
Yeah.
he took the symbol of the Hindu because he had a Hindu church across from his bedroom when he grew up. So that's the symbol. And he was an artist. So he created the Nazi flag and the Nazi symbolism. And he used to love opera. He used to spend all his money just going to the opera to see Tristan and Isolde, all of Wagner. He was in love with Wagner. And, he was an artist. So, yeah. Anyway, no, the Iranians are very smart. And unfortunately, they have a dictatorship of a bunch of ultra religious old zealots that apparently really believe this stuff because they're gonna get themselves killed in the process. I mean, they see that they're being killed, they're being targeted every day. Another one of their leaders is assassinated, but they keep playing
You know what?
Hmm?
There's this clip actually of Nick Fuentes talking about Sinwar because someone was saying Sinwar, he threw a stick before he was killed, and the
Yeah.
final act of defiance, and people
Yeah.
were like, "Wow," it's like so dumb, dude. Like they're getting blown the fuck out. Like they need to, like as Fuentes says, take the L. Like Jesus.
Wait, whose side is Fuentes on? The Nazis?
He's on his own side.
But he's he's a white supremacist.
Yeah, he is. Yeah.
Yeah, I mean these
But
people. Yeah. Hey, look, everybody's wrong. Everybody's wrong about everything.
Except you. I mean, obviously, right?
Obviously, I'm obviously the least wrong. If I can recognize that everybody's wrong, then already I'm the least wrong.
Mm-hmm.
No one has.
Socrates. Yeah.
I don't know anything about Socrates. I didn't hear good things about him either.
I don't like him either. I was just saying the
what?
there was a thing about him where someone said he was the most knowledgeable because he knew that he didn't know everything or some shit like that. The Oracle of Delphi had said he was the wisest or something like that.
I don't know anything about that, honestly. I don't really care. I honestly don't care.
You're not missing out. You're fine. Don't worry about it. It just reminded me of that.
I can only assume that he is as wise as the wisest men of this generation, and I really don't have any respect for anyone in this or any generation. So I've heard basically everyone speak, and I'm not impressed.
Maybe in the future they'll be better. You never know.
Well, if anyone listens to my shows and starts from that, they have a good chance of being very wise. Yeah. But without my show, without this knowledge, if they start from scratch, it's going to be a tough ride. It's going to be a rough ride. So anyway,
you were educating people yesterday about altruism, and you just didn't listen. They weren't hearing you.
Yeah, I mean, but she made a good point. She said, well, if you dial anything to 11, you're going to get crazy results. Like if I dial my egoism to 11, like you could say, oh, you're going to get crazy results. I don't know. I didn't think through dialing my egoism to 11.
I didn't even know if that's true, by the way, because like you're just looking out for yourself. Like,
but by looking out to for myself, right? Part of that is I want to live in a good like good neighborhood and a good
Exactly. Yeah.
society. So
Mhm.
I
I think
I
if you dialed it up, you'd probably be fine, unless you were really short-sighted about it.
right, right, but I don't, but being short-sighted, I don't know. Yeah, I guess you could be short-sighted, but but you never know how long you're gonna live. Like if you knew you're about to
Yeah.
die, I guess maybe what would I do if I knew I'm about to die in 5 minutes? How would I change my life? Like would I what would I do? Like I'm enjoying this conversation more than anything else in the universe. So why would I do
Mhm.
anything different? So
That's it.
I'm always optimizing my life. I'm always doing the best with my life.
Mhm.
But you never know. Like
Yeah.
I'm assuming that I have plenty more years to live as long as I don't do anything crazy. Anyway, so yeah. So about the solution, about the Middle East, we can talk about that if you want. What is the problem? And what is the solution? Or
The what?
the Middle East? Because I mean, you heard Zelensky, which is related. I mean, the whole thing is related. Zelensky from Ukraine said yesterday that if the U.S. is not helping, that Ukraine is going to get a nuke, and
Mhm.
if they need to, they're going to nuke Russia, start
Mhm.
nuking. Like if nobody's going to help them, they're not going to they're not going to go quietly. If
Yeah.
it's either we all die or we all live in peace.
Mhm.
So right, so the U.S. The U.S. had a deal with Ukraine. Give
Yeah.
up your nukes,
To
and
give up their nuclear.
we'll take care of you. We'll protect you.
Mhm.
But the U.S. is not. The U.S. Is unreliable.
Yeah. The thing was, one of the generals or whatever said they had intelligence about um the Russians using a tactical nuke. Shogu or whatever his name was in charge of the military over there, and they told him, "We know you're going to use a tactical nuke. Don't do it." Um, and there was a clip about it recently. Some interview with that author of book, what's it called, War or whatever. He had some intelligence about it or something.
Well, I don't think the Russians have been using nukes.
No, they haven't. No, but he said they were going to until the general told them to stop. The American general.
Oh no, I don't think Putin. Look, I think China is telling Xi Jinping told Putin to take it easy, like not to go
Hmm.
like Xi Jinping doesn't want to destroy the planet. Putin is a little bit
Hmm.
crazy. Putin, he's a mystic. So the problem is
Hmm.
the mystics. The problem is mysticism. So the Iranians are dangerous because they're mystical. The Arabs, the Muslims are dangerous because they're mystical. They believe in the afterlife. They believe in mysticism. This mysticism makes them behave irrationally.
Hmm.
So they go down fighting, which makes no sense. Instead of putting down your weapons to live another day and enjoy life. Like Sinwar is a multi-billionaire. He could have laid down his weapons and received a ticket to Qatar or somewhere to live out his life as a multi-billionaire.
He could. I don't think he could have done that because like he was wanted for. Well, maybe he could have actually lived somewhere, but he was wanted for like massacring people, like in Palestine, like Palestinians and Israelis, and I don't know
Yeah,
if they were ever going to let that
he
go.
would have. Yeah, he could have. Look, he didn't have to do October 7th. He did October 7th against Iran. Iran told him we're not joining you. He said let's
Hmm.
turn October 7th into a full-fledged war from every direction on Israel all at once. We can take them out. The Hezbollah said we're not doing it. Iran said we're not doing it. Everybody said we're not doing it. So he did it on his own. He did a tiny operation. He killed like 1,400 people and whatever. and
It's kind of a big operation. I don't know if it's tiny, but yeah, it's
it's
not as big as like
tiny.
America. But
It's tiny relative to taking out a country. I mean, he didn't take out a country. He wanted to take out Israel. So killing 1,400 people, that's like that's a statistical error. That's a statistical fluctuation. It's a country
Al
of
Qaeda killed like 3,000 people. So
what?
and they got Al Qaeda killed like 3,000 Americans, and they got absolutely fucked up after that.
So taking down the twin towers, that's significantly bigger damage because those were business centers. So the amount
Mm-hmm.
of damage, I'm not talking about the lives of businessmen. We have Chinas. Chinas has joined the chat.
Hey,
Chinas, did you hear the conversation with the trucker?
No.
Oh
What was it about? The Stern-Gerlach experiment?
no, no, it was about. I started with the black hole analysis, but very quickly I realized that he doesn't have any clue what my ether model is. So I went to the ether model, the gravitational ether paper, and he could barely follow it. Like just,
But
uh,
who's the trucker? Is it a professor?
he's not a
No.
professor, but he's a friend of a professor. Uh, like I had a conversation with an actual quantum researcher.
Yeah, so it's not that
so
one. Okay.
is he a professor by proxy? Is he his friend?
I
Yeah,
thought
Professor.
I thought that I thought that he would know much more. He knew a lot more than the average person, but he doesn't know enough that I can have a fluent conversation about my ether. Like
Okay, then I have no idea who he is anyway. So
right. So what I'm discovering is that even when I speak to actual professors, like I need to really go very slowly, very slowly, because they're barely able to follow. And one of the professors that I spoke to, he said, "Listen, I know in your mind it's very clear, but in my mind, I don't know what you're talking about." So I really need to make many
but
more.
he said that to you or you said it to him?
He said it to me.
Okay.
Like when I explained my ether model, they have so many, even professors have so many questions that it's I need to make more presentations. Like I need to make slower presentations that take everything step by step. Like when I say, why does the apple fall? I need to also I need to make sure they understand I believe in gravity, because they keep saying, "Oh, you don't believe in gravity." It's like that's their response. Oh,
Yeah,
you
because they keep like trying to relate it to something else that they already know.
exactly. They think I'm a conspiracy
Or
theorist, that I believe in a flat Earth. So I need to make a separate presentation that I don't believe in flat Earth. I don't believe in hollow Earth. I don't believe like the list of things I don't believe. I need to have a separate presentation. Who am I? Because
I just clicked on your
yeah, I
website,
get
and I really couldn't
it.
understand what you're saying about global warming. But you're like a Freeman Dyson fan, like
of course I'm a Freeman
oh
Dyson
yeah,
fan in many things, but also as far as global warming is concerned. Sure, you've heard of Freeman Dyson?
I
yeah, yeah,
haven't.
Da Vinci. I'm talking to you. You
yeah,
heard
yeah.
of?
I've heard of him. Yeah,
Really?
yeah. I mean, I've seen some stuff where he was talking about rockets and things like that. Like he was talking about bombs, like launch rockets were like explosives.
Yes, he was the original mathematician on um, what do you call that program with the nuclear bomb?
The
And
Manhattan
Manhattan
Project, or what?
Project.
Like, what do you mean?
yeah, he was in the Manhattan Project, but after the Manhattan Project, they had another project where they wanted to use atomic bombs as an engine, as the propellant.
Hmm.
Oh, I've never heard about that one.
Oh, let me show you. That's like you need to know that. That's
Yeah,
critical.
that's interesting.
So, let me see. His name is Freeman Dyson. Freeman Dyson Atomic Program Starship. So they actually had a plan for a starship, an actual starship. Here, this is the starship. Let me show you. I'm gonna paste it in the side chat.
Does this guy work for any like military government contractor, like Lockheed Martin or whatever?
Something like that. But first,
Yeah, because have you heard about like
but
Black
this is.
Manta,
But first,
one
look.
of those projects?
But first, look at the video that I posted.
Yeah, I'm looking at it.
Inside
Yeah,
chat.
like it's just like various explosions.
So this is
It's a bit weird
what
because
do you call
like
this?
there's like a drum on the back.
Let me find a better video. This is a terrible video. They don't explain it. They don't even mention the name of the program. What is the name of this program? The Orion program. So I'll give you the actual documentary copy link. I'm going to put it in
What's the name of
site.
the guy?
Freeman Dyson. So here is this is the Orion video unavailable, contains content from UMG who has blocked it from display. Watch on you. So I have to watch it on YouTube. And I can't share anything without destroying the stream. So you have to watch it on YouTube.
Nuclear
Oh.
propulsion spacecraft. Okay. There's an interview with him, I think, on Big Tink or something, where he's talking about it.
Yeah.
Not
Like, yeah. I mean, he is what they would call a denier. So I don't know, like, I don't know how they used to interview him without blowing their brains up. I mean, like, it's really weird. But fine, they did.
I guess he
Project,
already
I know
had.
what Project Orion is. I remember.
Let me
Project
try.
He already
Orion
had.
was
Sorry.
related to Lockheed Martin.
I think it was a government project.
Yes, but Lockheed Martin was subcontracted.
Okay, there is an actual, like a 4-minute video of this starship.
Or maybe not. No, maybe this is like earlier. Yeah, this is a lot earlier.
You can watch it on my stream if you want.
No, I'm seeing like schematics.
So the first stage is a normal booster. So this is the normal booster phase.
You should join StreamYard if you're going to watch YouTube.
Okay, here is my
Can you
StreamYard.
join StreamYard, Da Vinci?
Yeah, he's joined us before.
Okay, let's go.
Are you guys joining Premiere?
Yeah, I give you the link in the side chat. You have the link.
Okay, I'll check it out. Yeah.
So the first stage is just a normal booster. And as soon as basically you see now it's basically in outer space. It doesn't even go to orbit. And this is actually, yeah, I see you. So this is not the rate at which it's supposed to explode. It's actually 4 times a second. It's supposed to blow 4 atomic bombs per second. It's not supposed to blow up at that slow rate. It's supposed to be more like, and each explosion is actually tiny. It's like these are tiny explosions. Each atomic bomb is the size of a soda can, of a Coke can. And they actually, the technology to miniaturize the atomic bombs is still top secret. So the documentation for the atomic bombs that they designed are still top secret. The information has never been disclosed to the public.
Yeah, they're mini nukes. They will use on other things like.
No, this uses nukes. Of course, it uses nukes.
No, but you're talking about like the Project Manhattan in general, or like these types of.
No, this is Project Orion.
Yeah,
Project Orion.
You're saying that it's these types of nukes that weren't declassified, like these small ones.
Yeah, the miniaturized nukes are still we don't. I mean, they're still classified. Yeah.
Yeah, they were used on other things, though.
Miniaturized nukes.
Yeah, like trying to demolish. They tried to demolish buildings and make dig holes really fast and stuff like that. Yeah.
Anyway, so using the Orion project.
There is the theory that they used it on 9/11.
Wait, Da Vinci, Da Vinci's gone?
Yeah, Da Vinci has not joined the stream yet.
It's okay. He always comes back.
Or maybe he has, and I don't see him.
No, he's not. It's fine. I mean, I'll ask him, but he can come back later. Like he always comes when I need him.
Okay.
Let me just write. I guess you did not join. Oh, he is joining.
Okay, cool.
All right, shake. Yeah.
So.
Anyway, yeah, we can. I can hear you.
I can't hear any. Okay, I can't hear him.
I can, but maybe Da Vinci. Can you hear us?
Can you hear me?
Yes.
Oh, now I can.
Raise the volume. Maybe your volume is on 0.
My volume?
Yeah, raise your volume. Maybe it's on 0. I don't know.
How do I raise it?
No, I mean your laptop, your iPhone. I don't know. I don't know. Can you hear me?
Yeah, I can hear you.
Okay. Can you hear Chinas?
So.
Hey.
All right, so everybody can hear everybody. Anyway, so now we can share normally. Anyway, so let me see. So that's the Orion. How do we get to the Orion? Anyway, let's see what's up in the universe. This is not interesting. Not interesting. This guy has ring theory. He has such good animations, but I don't know what he's talking about. Such nonsense.
Wait, which guy?
This guy, ring theory, carbon, nitrogen, oxygen, whatever. He like if you go to his channel, all his if you look at his videos, just I mean look at the animations. Such beautiful animations.
He thinks everything is Taurus.
Yeah, everything is rings. It's like
It's like Sonic the Hedgehog, you know. Like collect the rings.
Yeah, I guess I know what you're talking about. He actually has the Stern-Gerlach experiment.
The moment of atoms is based on the deflection of a bundle of atoms in an inhomogeneous magnetic field, which is proportional to the component of the magnetic moment in the direction of the field. However, this experiment is not proof of the existence of electron spin. In an experiment in 1921 in which Gerlach collaborated.
So I have a theory why the experiment, right? The Stern-Gerlach experiment, some of the atoms go to the top, some go to the bottom, none of them go to the center. They're not spread out. The question is, why don't they spread out? So classically, I don't know. What do they do classically? I don't know. Like these, like everybody says, oh, classically they should have spread out. Why?
Yeah, but there's no reason for that.
Yeah, why should they? I don't get it. Why should they spread out classically? Like I don't understand it. Why should they spread out?
I think they think that atoms would have some resistance to changing the magnetic.
Why? I mean, look.
Yeah,
anyway, forget it. It's not worth it to talk about it. Like I give up. I just give up. Somebody posted something. Bob Woodward. What is that? Late Show. Bob Woodward credits Secretary with preventing Putin from. Da Vinci. What is that? Oh, that's from a while ago. Okay, it's not from now. Anyway.
Oh, sorry, I was muted. Sorry, I was saying that that video was just about the author talking to the general about the Russians were thinking of using the tactical nukes. If you wanted to check out his testimony.
Oh, okay. Let's see. What is the wave function? Oh my God. Oh.
What is the wave function? You know, like, is it really?
Oh, I didn't share it. Hold on. Sorry.
Wave function.
Wave function.
The wave function.
Wave function.
Isn't that Brian Cox?
A little bit of quantum mechanics, you have definitely heard of the wave function.
Why is the audio so low?
But what is a wave function?
Forget it. The audio is too low. I can't hear it.
You have to download it and.
I don't even know what the wave
increase the
function
audio.
is. It's not
VLC.
Not a big deal.
What's that computer program called? Wave function collapse. Have you guys seen that one?
No.
It's like a computer program. It generates art.
So it simulates that?
Yeah, it did. It just generates art based on some kind of predictive model or whatever. I can't remember. Was it who was it who did the video on? I don't remember. Was it Code Train or something like that? Let me look it up. Coding Train wave function collapse.
So somebody made a good video about the Stern-Gerlach. Why the Stern-Gerlach makes no sense.
The magnetic.
So this is discovery of spin but missed. So it's really strange. This is really
In the previous video, I showed you the physical and historical context as well as the motivations of this Stern-Gerlach experiment. Now,
What happened? Da Vinci, did you say something? Da Vinci, he keeps muting himself. Yeah, you keep muting yourself. Can you hear us? Da Vinci. Oh my God, this guy.
I want to explain why the results are correct, but for the wrong reasons.
So this guy has the theory. This is Dr. Jorge S. Diaz, who is Jorge. So he's not a joke, obviously. So
I saw one video from this guy and it's extremely boring.
No, he's very good. I appreciate him. I wrote him an email. So he's a theoretical physicist creating educational content. I share stories about he goes very deep. I really like his analysis. I don't have a problem with his analysis. But here he claims, what's up, Givenchy? Can you talk?
Yeah, I just got disconnected for some reason. When I play a video on YouTube, I get disconnected.
Oh, okay.
And the videos, I have them set to play automatically, and when you go through the For You page or whatever.
Okay, I don't know what you just said. I'm sorry. But anyway, so this guy has a theory that, first of all, Stern and Gerlach were not physicists. Did you know that?
No.
Like, I think they weren't. I mean, this is the Stern, I think, is a chemist, a physical chemist, and Gerlach is like a lab, an experimentalist, but he's not a physicist. These were not physicists. And I don't think they understood Bohr's model.
I mean, even that doesn't matter. Bohr's model isn't correct. It's just an approximation.
No. Bohr's model is absolutely correct. There's no issue
Of course not.
with Bohr's model.
He wasn't even trying to be correct.
No. Bohr's model gives very accurate predictions about
That doesn't matter. Predictions don't matter.
Okay, so all right. So I don't
know.
What do
you
mean?
can prove something through predictions. You can only dismiss something through predictions. That's the only value of predictions. Something predicting something accurately may be totally wrong. Like I can give you a model that's just like the sun god has a certain schedule, and it predicts everything perfectly. So, yeah. It has nothing to do with reality and what's actually happening.
So they say he received his doctorate, measurement of radiation. I don't know, but from what I understand, neither of them was a physicist, and I think they did not understand Bohr. I'm like, because they keep talking about the quantization of space. Show me where Bohr spoke about quantization of space. What are they talking about?
Yeah, but what's the quantization of space?
I don't know. But they didn't like the quantization of space. Anyway, so this guy has a theory that he says they were right for the wrong reason. Listen to what he says.
Context, as well as the motivations of this Stern-Gerlach experiment. Now, I want to explain why their results are correct, but for the wrong reasons.
Did you hear that? He's going to explain why they got the right results for the wrong reasons.
This is a follow-up video. Stern-Gerlach experiment.
So, anyway, he says that it's not even about spin. I don't know what to say to that. What do you mean it's not about spin? I don't know what's going on. Honestly, I don't know what's going on. What do you mean it's not about spin? Bohr's model is about the electron spinning around the nucleus. That's all it's about.
But is that spin?
If that's not spin, then what is spin? Well, what is spin?
Yeah, that would make it so that the electron wouldn't have spin in isolation.
Why not? Why would it not?
Not going around anything. Unless the electron is always going around and around and around for whatever reason.
That's a good question. So, I don't know. So what is it doing? Okay, so then what is it doing? If it's not going around, look.
The problem with Bohr's model is just like it makes some predictions, but it's clearly not correct.
Like
I
what?
don't think it's
What's not
considered correct? Like the Bohr's model.
What's
it's
not
considered correct today, obviously. And
what's not correct? But wait, what's not correct about Bohr's model?
Everything really. It's just the model. It's just a model that makes some predictions. There's nothing to even.
But you have to say what is not correct about the
Okay,
model.
I can. Like, I mean, it's really the entire model. Like, the electrons don't go around an atom like
Yes,
that.
they do. Oh, yeah,
No,
of
they
course they
don't.
do. Okay, what's your evidence that they don't?
It's my evidence that they don't. I mean, it has been measured.
What's
That
your
they don't.
evidence?
They
What's your
are.
evidence? What's your evidence? Show your evidence that they don't, right? We have the Stern-Gerlach experiment. Based on this experiment, it's clear that the electron spins around the nucleus, creating a current around the nucleus, creating a magnetic moment pointing from the nucleus, and then it gets aligned with the magnet, and that's why the beam splits. This proves
Wait.
this
It's
proves
it's a current that creates a magnetic field. Is that what
this
you're saying?
this,
So,
this proves this experiment single-handedly proves Bohr's model.
no, that doesn't prove Bohr's model at all. That doesn't
Then
even prove that the electron is a particle.
I'm not saying Bohr never said the electron is a particle. Bohr actually said the electron is not a particle. The electron is a wave around the nucleus.
So the wave
That's
going around the nucleus, is that what it says?
that's what Bohr said, and that's the simplest interpretation. That's what Schrödinger said, and that's what de Broglie said. I mean, this is just if you go back to Planck, you start from Planck, that quantized energy, and Einstein
How does that wave go around the nucleus?
What do you mean? How does a wave? It waves around the nucleus. You want me to
In which
draw it?
direction? Is it convergent, divergent, or is it a rotational
It's a
wave?
wave. It's
No,
just a wave.
No, look. Is it like divergent, as in like it's moving away from the nucleus, and then maybe it converges again, or is it like something that just goes around the nucleus? That's just like a wave front moving around the nucleus. I mean that I think that there's some problems with that. Let me see like pictures of atoms.
No, here I'm gonna draw it. I opened. You can see my screen, right?
But we have pictures of hydrogen atoms and so on.
No. This has nothing to do with any picture you've ever seen. So you have the nucleus. Oops. You have the nucleus at the center. Let me start over. There is the nucleus. And the electron, here is the orbit. And the electron waves. Imagine a wave, like a fluid, that sometimes it has compression and sometimes it has depression. So compression,
So you think the wave goes around?
depression. It waves around, yes, like a normal wave. This is a wave of ether. That's what it does. It waves around. It doesn't move. There's no motion. Nothing moves. This is what Bohr described, and this is what Schrödinger described, and this is what de Broglie described. That's what they all described. This is what Einstein described. Whether they like it or not, whether they agree with what I'm saying, I don't care. But to me, that's what they described. This is a very simple explanation of what an electron
But that
does.
looks different from the images we have.
I don't care. This is what it does.
Yeah, but the images are the important thing. That's
No.
the
What
evidence.
images? What images?
Oh,
What do you mean images?
images.
What do you mean images?
Wait, no, I joined. I'm gonna go to the side chat. Right.
You mean Schrodinger's equations predictions?
No, I mean the images of the atom
What do you mean images?
with electron microscopes.
What do you mean images? Like you're not giving me a link. You're not. Did
Well,
you
I
give
gave
me?
you a link. Yes,
Okay, I see the
I
link.
gave you an image.
Okay, so I don't know. I don't know exactly what we're seeing here, but this is some
An
sort of a.
hydrogen atom.
Hold on. So I don't know. Let me just finish the sentence. So I don't know exactly what we're seeing here, but obviously this is some sort of something waving.
Yeah, basically what they do here is that they send some photons, I think, and they see where they're blocked. So they're
Let me
always
see. And
blocked in the nucleus.
let me see. Electrons have quantum properties, so can be in many places at once.
Yes,
Electrons have
that's a
quantum properties,
terrible
so can be
sentence.
in many places at once, making it hard to image atoms. By combining snapshots of many electrons at once, so as I said, I don't know what we're seeing. Hydrogen atoms have now been imaged at 4 energy levels, increasing from A to D. So, look, I don't know what we're seeing. Honestly, I'm not like I'm just telling you. I
Yeah, I'm
honestly,
telling you. So they basically shoot. I think they shoot like photons. They shoot light.
I
I
understand,
think.
I understand, I understand. But as I
I think
said,
that's what they
it's
do.
not.
But I will
I
confirm.
understand. I understand. I can come up with a theory of what we're seeing. I understand.
No, but like they have a process.
Look, at the end of the day, I don't know. Let me just finish a sentence. Let me just finish a sentence. Look, I don't know. I'm not saying. I'm not taking any position. I don't know what we're saying. However, it's clear that this is something waving. This is something. This is not in any way contradicting what I'm saying. So, this could easily be explained as the torus that I'm envisioning. This is a torus. It's not rotating. It's waving around. It's waving around.
More
Maybe
likely, this is a sphere.
no, no. It's not a sphere. A sphere, everything would be the same color. It's not a sphere. This is the nucleus. You can see this is like at an angle. I don't think it. No, I don't
No,
think it's a
it
sphere.
needs to be. It needs to be kind of a torus. Yes.
It has to. As far as I'm concerned, it should be a torus, some sort of a torus, and that is the first orbital. As far as I understand, it can't be a sphere. The notion of a sphere doesn't make any sense to me. I don't see how something can wave with the shape of a sphere. At the end of the day, Schrodinger's equation is just the wave equation applied to the conditions of what we know is the hydrogen atom. So we know there is Coulomb's forces, and we know there is energy conservation, momentum conservation. He just threw in everything we know at the electron and added and plugged it into the wave equation.
With Schrodinger's wave equations, it looks like this.
Yeah, I know. It doesn't matter. It doesn't matter.
Someone
At the end of the
commented
day,
saying it's wrong.
what?
Someone commented saying it's wrong. There, Rodolfo Pitti says it's wrong.
What's wrong?
Rodolfo Pitti said
No
it's
idea.
wrong.
Yeah.
Rodolfo Pitti, you have the link. You can join the StreamYard and explain to us what's wrong, who's wrong. I don't know. I don't know what is it's. It's wrong. But the universe is wrong. Anyway, so at the end of the day, both de Broglie, Planck, Einstein, de Broglie, Bohr, and Schrödinger said the same thing to me. They said that the electron is a wave in the ether. It's waving, it's not moving, it's waving. It's attracted because of the Coulomb's force or a gauge boson particle exchange. You can interpret it doesn't matter how you interpret it, but there is an attractive force. It doesn't move, it doesn't rotate. I mean, it just waves around. It has a mass, it has a momentum, but that's the wave's property. So it doesn't. I don't think it needs. I don't think it needs to move. There's no moving around. It's just a wave. It can't. Sorry, it cannot move because it's a wave. It waves around. It simply cannot move. There's no. The particles of the ether don't move. That would cause a turbulence, and my ether is laminar. It's not turbulent. So nothing is moving. This can only wave, as far as I understand. And based on all the conditions that I'm aware of, such as energy conservation, momentum conservation, lambda, the wavelength, the Boyle equation, Planck's constant, based on all the information that I have and the fact that it's a wave, meaning the wave equation, this should be a torus. It cannot be a sphere. I cannot see a sphere. I cannot understand how a sphere can be a wave. So it cannot be a sphere. So it must be a torus. That's one configuration. I don't know. I don't know. I mean, look. So a wave. This can wave with a single wavelength. That the entire perimeter of the electron of the atom is a single wavelength. That's the first energy level. If we throw a photon at this electron and bump it up one energy level, so instead of the perimeter of the circle of the sphere of the circle being a single wavelength, we go up to 2 wavelengths. It would have some other shape, maybe. I don't know what these pictures are. I just don't know. But you can have different configurations, I guess. I mean, this can wave in all different ways. There's many ways in which this can wave. It can wave around. It might be able to wave side to side, maybe both side to side and up and down simultaneously. It can wave, in 3 dimensions. It's pretty much free to wave in every crazy sort of way that it wants to. Nothing is stopping it from waving in crazy ways.
Yeah, but the way they did this is also it's also has to end up looking like this. Because what they did is that they shine some laser at a bunch of hydrogen atoms, and then they saw like the interference pattern that was caused by shining that laser.
The problem with shining light at a hydrogen atom at the electron is that the electron absorbs the photon, and it bounces up and down in the electron shells and in the configuration, in the way it vibrates.
And not just that, it's then they just get like their re-emitted light as well.
Yeah, so I don't know. Look, it doesn't matter. This is what Schrödinger predicts. I don't have a problem with Schrödinger. Most of the time, I don't have a problem with Schrödinger. As long as you can imagine, as long as you can classically understand how it's vibrating, and I can see it vibrating in basically almost infinite ways. It can vibrate in every way it wants. I mean, it's like it's a wave that can wave any way it wants in 3 dimensions, as long as it obeys the conditions that we agreed on. Energy conservation, momentum
conservation. This picture is
conservation.
not good.
Excuse me?
This picture is not good at all. Yeah.
No, I don't care. I don't have a position. As long as the point is, I believe in a mechanical universe. So to me, the electron is a wave of a fluid called ether. And as long as we have conservation of energy, conservation of momentum, and the rest of it, and we can only wave, the electron can only wave in integral multiples of the wavelength of its built-in wavelength, which de Broglie defined. Apparently, that's it. And it's really very simple. There's no reason. Like when you listen to physicists, they give you explanations that you simply cannot understand. But I don't see why they go to that place that they cannot understand when they can go to a place that they can understand. Like what's it's like they have this need to not understand this universe. It's like a need.
I mean, if they understand everything, then they don't have any more research to.
I'm not even judging.
I
Like
don't know.
even when you
It's not because of that. It's because it's just like people have a tendency to do some magical thinking. That's normal.
yeah, it's a
Yeah.
tendency. It's a tendency to believe in a magical universe, and we never got rid of it. Like we thought we became we became scientific and atheistic, and we shed this belief in a magical universe, and but we didn't. Like when you speak to people, they don't accept they don't like a mechanical universe. They hate it.
Yeah, I mean, if the universe is mechanical, it means it's simple and it's understandable by everyone.
Yeah.
So I think some people do have a problem with that.
Look, you debate people, and you see the amount of anger they have with a mechanical universe. Just the assumption, just when I bring up my assumption that it's a mechanical universe, they want to kill me. It's like you see the debates. No debate. No debate goes without personally attacking me
Yeah, that's
endlessly.
weird.
Exactly.
Like we're not even
Exactly.
if we're talking about like something that was like a war,
Yeah.
I could understand that, but like about physics, I don't see it.
Yeah. Really weird.
It's so weird.
So as long as we can understand something is waving, like as long as you have in mind this is waving and it conserves energy and momentum and it has a wavelength and it can only wave in the total length of the wave is an integral multiple of the wavelength. Now I don't know how
that
I
does make
don't know.
sense.
Yeah, I don't know what this is. I honestly don't know. I mean, I don't know. This could be that they were firing some light at the electron and it kept bouncing up and down, up and
No,
down, up and
it's even
down.
a little bit more complicated than that. Like they excited the electron. They fired. Okay, so basically they fired some light. Let me recheck just so I don't say something.
I honestly, I don't see
They added a nitrogen beam.
no,
And
I
then
don't see. Listen, I don't see the difference between these three. Like B, C, and D look
wait,
identical to
PCND,
me.
wait, I have to PCND. Okay.
They all have like an outer ring and an inner ring. It looks like different angles. I'm not so sure. It looks like they tried to excite the electron and then it collapsed, excite again, it collapsed, excite again, it collapsed. So they got two
Yeah.
states, maybe they got two different orbits in the same image. These are maybe two. Like in the first
Yeah,
one,
these
it's a
are
single.
various different orbits. This is like the probability distribution for it.
There's no probability. That's nonsense. There's no probability. There's no
No, but this is
distribution.
like no, but these were many attempts.
Yeah, but
Right.
there's
So
yeah. These
some
are
of them
many.
hit the center, and some of them hit not so close to the center.
No. As I said in the beginning, I don't know what we're seeing. I don't know. So I don't know why they have these dots. I don't know what these dots represent.
Okay, I'll tell you. So basically, they had a beam of hydrogen, and then they used to separate.
What is a
lighter.
beam? What is a beam of hydrogen? I don't know what that is. What's
Yeah,
a beam of hydrogen?
it's like a beam of silver atoms, you know.
No, I don't know. A beam of silver atoms. I don't even know what that is. I mean, you can. So I'm not even sure what you mean. I don't know what a beam.
I mean, they shot a
know.
bunch of hydrogen.
No, no. If you shoot a bunch of hydrogen, you don't get snapshots of a single atom.
Yeah,
They
but
somehow used. They probably used a laser beam to suspend a single
that's probably
hydrogen.
true.
They usually use laser beams to suspend atoms because you can use the vibration to cause the atom to be suspended, and then they took snapshots. But these snapshots, then everything is confused because you need the laser to keep the atom at one place, and the atom is now reacting to the laser. So you're not getting an unmanipulated image. You're always getting some manipulated image. You're not getting the authentic hydrogen atom. You're getting an excited atom that you're taking multiple snapshots as it is excited, and then it collapses. Excited collapses, and and maybe it goes into a vibration because of this excitement collapsing. Maybe it goes into some eigenvalue because of that. I don't know. I just don't know.
Yeah,
It
essentially, it's that.
but,
Like
but
you're
it's fine.
really
It's
interfering a lot with.
look. The point
with-
is, don't let this confuse you that these dots are the electron. The dots are not the electron. The electron is a complete wave. It is, as Schrodinger described, the wave equation describes the electron density, not the probability density. It describes the electron density. The electron is a wave, and as it waves, it has a density. So it has a high density here and a low density here, and a high density here and a low density here, and a high density. That's all. That's all it is. It's just a wave. It's just a wave. That's all. Very simple. No, you don't need to be confused by this wave compared to other waves. It's just a wave. Now, it can wave in different ways. Oh my God. So one way is for it to wave in a circular pattern, but another way for it to wave is right. Looking right. This is the nucleus. You can imagine that it's waving like this. It's waving like this and like that. So it's bobbing up and down. I'm looking from the side. So this is it's the orbit, but this is bobbing up and down. This is bobbing up and down at the same time. Both are bobbing up together, while this is bobbing down in the opposite way. So when this is up, this is up, this is down. And that's what you see here.
But
Up.
wouldn't that produce light waves?
Um,
Maybe not. Like it needs to be contained. That's the thing. Like the energy needs to be contained.
Look, we know when it does and when it doesn't. It creates light waves when it falls from 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 one high energy orbital to a lower energy orbital. That's at least that's one time. Like here is the nucleus. So if you add a photon, it swallows a photon, it goes up, and then when it comes back down, it releases. It doesn't release, but it falls into its lowest energy state and it crashes. And that crash creates a vibration. That's when it creates a vibration.
I mean,
So you have some sort of a photon wave somehow absorbed by the system that causes the electron to go up from one lower orbit to a higher orbit. But that's like a ball on the top of the hill. It's unstable. It takes zero energy for it to fall to one of the sides. So it's unstable. Anything that happens, any tiniest vibration in the ether causes it to fall back down to the lower state. And when it falls down to the lower state, this is the lowest. This is the lowest. Right. This is n equals 1. Oops. N equals 1, and this is, let's say, n equals 2. So it can't go under n equals 1. So it basically crashes, and that's when it releases the same wave. The same wave packet that it took in then comes out. I don't know exactly the mechanics of how that happens. And that's photon in, photon out. That's conservation of energy of the system.
Mhm. Okay, yeah. But either way, like I don't know, like that makes me think that.
So, okay, let's go to Stern-Gerlach. So what did Bohr say? So Bohr said you have the nucleus and you have the electron waving around. It's not spinning, it's waving. I don't like using the word spinning. Spinning sounds like there is a sphere here that is moving around at a radius r. That's not what's going on. That is an incorrect interpretation. That's not Bohr's model. Bohr's model is you have a nucleus and you have an orbit, and you could either, draw a line like this, or like what I said. The better thing is to imagine compression, decompression, compression, but usually the first wavelength means that half of it is under compression, the other half is decompressed. And then that is a single wave. That is n equals 1. N equals 1 is one half is under compression. So when you look at it like this, so it goes up and down and back down. It's a perfect sign. The point is that it's continuous. It has to. It can only be n equals 1, n equals 2, and so on. It must be an integral, because otherwise you have a discontinuity in the wave. So lambda is given. Because the wavelength is a given, because of de Broglie, lambda, the wavelength of the electron, is a given. You cannot change it. So because of that, everything else is predetermined. Because the mass is given, and so the velocity is given. This is the velocity of the current. There's nothing moving. It's the velocity of the current. It's a current. It's an electric, it's literally an electric current. This is an electric current. This is a wave of electric density. Literally. This is exactly what we define, right? When you have a wire and there's current in the wire, there's just an electric density. There's waves of electric density. That's all that there is. It's a wave of electric density. The electrons are barely moving. Each electron is barely moving. But the wave is moving very fast. I don't know at what. Maybe at the speed of light. But that's the wave. Probably not the speed of light. I don't know.
No, I think
But
that should be like...
The point is, it's not electrons moving. It's electron density. That's current. This is electron density. This is current. This is electron density. This is current. Nothing is moving except for the density of the electron. These are the words of Schrödinger. When Schrödinger was asked, what does the wave equation describe? He said electron density or electric density. That's it. That is current. So you have current. Therefore, you have a magnetic dipole. That's it. You don't need anything else. That gives you a magnetic dipole. That's a magnetic, you have a magnetic moment. That is the magnetic moment. That's it. You don't need anything else. That is what Bohr said. I don't know how to be clear. I don't know why everybody misunderstands Bohr. It's so simple. So that's it. Now, is the magnetic moment, is it quantized? Well, the velocity, the mass is quantized. The charge of the electron is quantized. Lambda is quantized. It's a given lambda. The velocity of the current is quantized because everything else is quantized. Everything is quantized. Once you start from m being quantized, you're done. Because m is a quantity, you use de Broglie and you have a certain wavelength. And you cannot avoid it. It's a one-to-one. And this is a one-to-one. Everything here is one-to-one. Everything it gives you quantized quantities. And this is also, I think this is also, there's conservation of energy. So the magnetic moment is quantized. The electric current is quantized. Everything is quantized. Why are you surprised when suddenly the angular momentum is quantized? Because everything is quantized. It's not like Bohr woke up one morning and he decided that the electron is going to have a quantized mass and a quantized electric voltage. I mean, Milken, I think, did the experiments. Milken got these quantities. The electron is a known quantity. It's quantized. The electron is quantized, and all electrons are identical. So it's quantized. Therefore, the angular momentum is quantized. Therefore, the magnetic moment is quantized. Now, is the space quantized? No, space is not quantized. This can point any way. This can point any way you want. Nothing. There's no predetermined. It can point any way you want. Anyway, but the magnitude of the magnitude is quantized. The magnitude is quantized. That is quantized. The magnitude is quantized. Yes, but not the direction. The direction is not. The space is not quantized. The Stern-Gerlach experiment is completely classical. I don't understand why. What did Stern-Gerlach have in mind? Kill me, please, if I understand what these two idiots had in mind. What did these two idiots have in mind? What did they imagine? What is quantization of space? I don't know. I don't know. I don't know who these people were. I don't know what kind of a bad day they were having that they ended up saying this nonsense. That according to Bohr, they called it Bohr's nonsense. They had enough of Bohr's nonsense. What is Bohr's nonsense? Space quantization. Okay, where did Bohr say space quantization? Did Bohr say space quantization? Did Bohr say space quanti?
I think he did. If not,
He did?
Einstein,
Let me see.
if not Einstein did it.
Bohr's space quantization. Okay, based on provided search results, it appears that Arnold Sommerfeld, not Niels Bohr, is credited with the content. Okay, then it's not Bohr, it's Sommerfeld. I don't know who Sommerfeld was. Okay, Sommerfeld quantized the z component of the angular momentum, which allowed for the orbits of the electron to be ellipses instead of circles, and introduced the concept of quantum degeneracy. I don't know. Bohr's model, while influential in development of quantum mechanics, does not explicitly mention space quantization. Instead, Bohr's work focused on the quantization of energy levels and the angular momentum of the electron. Okay, so it's another guy. Okay, in the context of the Bohr-Sommerfeld model, the quantization of angular momentum is referred to as quantized angular momentum or Bohr-Sommerfeld quantization, but not specifically as space quantization. It's worth noting that the term space quantization might have been used in later discussions or interpretations of the Bohr-Sommerfeld model, but it is not a direct quote from Bohr's work. Okay, so they misattributed space quantization to Bohr. That's the first one. I'm telling you, these people were idiots. Like, at least attribute the wrong theory to the right guy. I don't know. I don't know. What is this ellipses? Why would you have an ellipse? I don't know. I guess you can have an ellipse. I don't see why not. Why can't you have an ellipse? I mean, I think that orbits are more stable as ellipse rather than spheres or circles. We know that from the orbital mechanics. So it might be that ellipses are more stable. Okay, so I don't see the relevance. I don't know. And there's no one to ask. When I talk to experts, they so quickly say, look, I understand it with the math, with the advanced math, and they're too lazy to think about, the Aether model and the mechanical interpretation of the electron. Like I was speaking to this guy, this PhD researcher, and he said, look, to me, it's completely intuitive the way it is with the Dirac notation and with all the very, very complex math. It's become intuitive to think of it in that way. All right, so, it's impossible to talk to these people. They live in a dream world that I cannot relate to. The Bohr-Sommerfeld model. Structure of a radium. Oh, look, as long as it's waving, as long as this is a wave and this is a wave, as long as these are the orbits of waves, I don't care. What do I care? Why should I care? It fits my model. I don't have a problem with it. I'm fine with it. 5 electrons with the same principal and auxiliary quantum numbers orbiting in sync. Yeah, but they're not moving. What's important to understand, they don't move in space. These are not particles moving in space. These are waves waving. It's a complete wave. It's one complete wave waving. And then you could say that when the compression is here, the depression is here. You know, they don't wave at the same time. So you can have different configurations of waving. You can wave however you want. Ellipses, circles. It makes sense for them to be ellipses because they're repelling each other. While being attracted to the center, they're repelling each other, so it makes sense for them to acquire weird shapes. It's fine. I don't care. I mean, it's beautiful, but you can have a numerical solution probably better than trying to explain this mathematically. I mean, working this out mathematically is such a headache. What a way! Like, I can't believe there's a worse waste of time than to solve these differential equations analytically. You can easily solve these equations numerically using computers, computer simulation, and that's it. Give it to a computer. A computer will show you what it looks like. A computer will give you different configurations, and it's going to be perfect. Everybody's going to be very happy. And then there is also relativistic effects. I don't have a problem with relativistic effects. You can account for everything mechanically. This is mechanical. You don't have to lose your mind with this pure mathematical interpretation. Like, you talk to people, they tell you it's a mathematical. It's like when they say math, it's like when the ancient used to say God, 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 God. You don't have to attribute anything to a higher power. You don't have to say math. You can just say, this is what it looks like. What is the problem? Explain to me why you don't want this to be real. What do you lose if you say that this is actually real? What's the issue? What say you, Mr. Chinas? Are you there? Chinas! He's gone. Chinas, where are you? Yeah, when he doesn't talk, that means he's gone. All right, let's listen to this guy.
Experiment. So make sure to check that video for context. I would like to emphasize how lucky Stern and Gerlach were that they got the correct result at all.
This is ridiculous. So even this guy, he says that it was luck, meaning I don't know what they were doing. I don't think they knew what they were doing. Obviously, he thinks they had no idea what they were doing. So no one knew what they were doing. They didn't know. Nobody knows. I don't know what they were doing.
In addition to all the issues that plagued the experiment, from plane crashes to hyperinflation, there were a series of lucky mathematical cancellations.
So the whole thing was lucky mathematical cancellation. With all this crazy math, they got lucky? This means this is a complete waste of time. I don't know what is going on here.
The fortunate coincidences that led to their success. I told you about the bad cigars that helped Stern and Gerlach to see the silver atoms collected by their detector, and the millionaire banker that donated funds to save the experiment.
Wait a minute, I think I know this building. You see this when you take the ride around Manhattan. I've seen this building. I think you see this when you take the cruise around. Yeah, in New Jersey. Oh, it's in Jersey City. Oh, okay.
But there were more instances of good fortune. The day of the successful result, February 8, 1922, Gerlach sent Otto Stern a telegram simply saying, Bohr is right after all. He also sent him
Bohr is right after all. About what? You never understood Bohr.
A letter with details and copies of the now.
This is classical. Why would you say this is not classical? What is not classical about this?
historic photograph. The experiment finally worked and confirmed the speed of the atomic beam in 2 equal parts, as predicted by
The split, not the split. I thought he said speed. Chinas, where are you? I can't hear you.
I'm here.
Where were you? I kept yelling. You didn't answer.
Oh, I fell asleep. Sorry.
Oh my god. Are
I
you
fall
working
asleep very
tomorrow?
easily.
Wait, you're not working tomorrow.
No, I'm not working tomorrow, but I fall asleep very easily. Sorry.
Oh.
Yeah.
Anyway, do you want to do this? You want to go to sleep?
Oh, I can do a bit more.
Okay, but I don't want you to fall asleep. So you want to talk?
Sorry.
Do you want to say something? Do you like?
No,
do you-
sorry about that. Like, just happened.
No, it's fine. I'm saying, do you want to? I don't want like. Do you want to say something? Do something? I don't know. I like if you. Otherwise, you should go to sleep. We can like continue tomorrow or something. I don't know.
No, we can go for this video today, and then we close the issue today.
No, this video you cannot listen to this video because this video depends on the previous. This is part 2, and the previous you can't
I've-
understand.
I
They
think
all
I've seen the previous.
Yeah, I didn't see it enough. I need to go back. I need to listen. You basically have to listen to everything from the beginning. You can't really. You have to watch the first one first, I think, because I went back to the original, to the previous one, and I saw that it depends on the previous one. I went to that. I saw that it depends on the previous. Like, he keeps referencing. He always starts by saying, "In the previous video, we discussed this and that." So you always
The
you
strategy.
I don't know if it's a
Watch
strategy,
more
but
videos.
no, it's
So,
fine. It's like if I had to explain something, I would not want to start from the beginning of the universe. It's you I would not survive. You need to tell people, listen, either watch the previous videos or leave me alone. Like, I don't care. I'm not here to repeat the material. Okay, but we can listen just a little bit. Let's see.
quantum theory of Bohr, Sommerfeld, and Debye. Gerlach also
It's very interesting. This Debye, you know who Debye is?
stated by the quantum theory
Debye is the guy who ended up inviting Schrodinger, and at the end of Schrodinger's lecture, he asked Schrodinger, "It's very nice the presentation that you gave us about Bohr and de Broglie and the waves, but can you tell? But if there is a wave, then what is the wave equation?" And Schrodinger said, "Hold my beer," and he went away, and he came back with Schrodinger's equation. So that's Debye. So Debye is the guy that invited Schrodinger to give his famous lecture. And then he was the one who asked at the end, where's the wave equation? So I think that's Debye. I don't know. I don't know what he had to do with Bohr. And I never heard of Sommerfeld, and so I know Bohr very well. At this point, Bohr to me is God. Like, I used to hate Bohr because he argued with Einstein, but now Bohr is God because he gave us the original wave equation, the original wave interpretation. Like, he did the most out of everyone. I think he did the most work. Like, out of everyone in this story, his was the biggest giant step. No one gave us a step the size of Bohr. Like, he took de Broglie, who gave us a conjecture, and he showed that it gives us the spectral lines of hydrogen. He took de Broglie and he created a model that gave us the spectral lines of hydrogen that we use until today. He explained the spectral lines. Those spectral lines are when the electron falls from one orbit to a lower orbit. And he gave us, it fits the data perfectly. So to me, he's the biggest hero in the story right now.
theory of Bohr, Sommerfeld, and Debye. Gerlach also sent a postcard to Niels Bohr with a copy of the microphotograph.
Bohr probably got this and said, yeah, what's the question? Like, what is the question? What don't you understand? Bohr was probably so confused. Why did anybody test? Why did you have to test it? I mean, there's already other. I mean, Bohr gave us a prediction about the spectral lines. all you need is that's all you need.
But
Photograph
what's that?
of the split.
Postcard? What's that?
This
Yeah.
this is the split. This is like half of the electrons, half of the silver atoms were up, and half of them were down.
In
Before
the other
the
one.
this is before you apply the magnetic field.
Okay.
So
So it's not really a split. It's like an opening.
the split is there's
Yeah, that makes sense.
that it's not a linear distribution. It's half of them are up and half of them are down. So I don't get it. Like the magnet points up and down. Why would you expect anything to be in the middle? Like, tell me why.
Yeah, this is perfectly like that picture is perfectly expected. I don't see what's the
Like if this is the before, then this is a perfect after. Like you could say,
yeah, like the before isn't even like people say that it's just more distributed. It's actually the opposite situation that you hear about. Like without the magnetic field, they all go to the same place, and with the magnetic field, they split. It's not
look,
like
the
they're
point,
more.
no, but the
Yeah,
point, what I discovered something that no one discusses. So everybody says, look, it's split up and down. It only split up and down. But
It's
if you
actually
expected
somewhat
it,
distributed, like
hold on. Listen,
classically.
listen. Hold on. Listen. So the claim is that classically it should be completely distributed up and down. It should be full. It shouldn't be empty. So why is that? Because the magnetic moment, it would have precessed and undulated so that you would get it should be completely full. You should get some of them at the center. They should be everywhere because it couldn't have stabilized. The claim is that it didn't have enough time. The atom doesn't have enough time to stabilize at the down or the up.
Why not?
So because it cannot lose energy. A single atom simply cannot lose energy. So if you put it in a magnetic field and it starts precessing, it doesn't stop precessing ever. It will forever precess. It's not going to stop precessing. Why would it stop? It's like a mass and a spring, or like a pendulum. Like a pendulum is under constant gravity, but it swings back and forth forever. So under a magnetic,
no, but it's pushed when it starts. But the idea of precession is
why would it stop precessing? Why would it stop precessing?
why did it stop precessing? It's not like it would stop precessing. It's just that if it's passing through a magnetic field, it's under constant force.
Yeah, like a pendulum is under a constant force and it forever undulates. So there's no reason
but
it
it's
doesn't.
more like the pendulum is just being kept on one side.
No, the pendulum is always under a constant force of gravity, but it always undulates. It always.
Yeah.
So if you have a magnet, like when you have a compass and you let it go, and the needle, it starts undulating back and forth, and as it undulates, it loses energy because of the friction, and then it stabilizes pointing at the north.
Yeah,
But
that's really point. Yes.
But a single atom has no way of losing that energy, and a single electron has no way of losing that energy.
Oh, I see what you're saying now. Yeah,
that's the whole point of this experiment. That's it. That's the whole point of that the electrons should not lose the energy, and they should always be undulating. it should be completely spread. How could the electrons lose energy? They don't have enough time to lose energy, and they don't have the magnetic field, whatever. According to the calculations, they should have been completely spread. There's no reason for them to be more up or more down unless there is space quantization. That's these two idiots, Stern-Gerlach. That's their genius. They said that's the way they understood Bohr, that this should be precessing back, and therefore back and forth, and therefore a complete spread. There's no reason for it to be more up or more down than more in the middle. It should be everywhere.
Okay, wait a minute. If the force is completely in one direction.
No, it's not.
No, wait. Like, for example, even in the needle, even without friction, if the force keeps pushing the, like, okay, so if the force keeps pushing the needle, okay, it won't stop precessing, but no, this is a little bit different, because you have to picture the needle as it's moving through a field.
There's no reason for it to ever stop precessing.
Wait,
Unless you tell me, why would it stop precessing?
because all right, I'm trying to think about, like, because the atom is being accelerated. That's the problem. It's being shot.
No, it's not.
Yes, it is. That's the problem.
No, it's not.
Like, yes, it is. Like, you shoot the atom in a beam.
No, you don't. No, there's
Then
no
what-
shooting. No, you're not shooting. This is a furnace. A furnace, you're burning silver atoms, causing them to evaporate theoretically one by one. They go through a very thin, narrow slit, actually two slits. I'll show you the apparatus. And one second.
Yeah, I can see it in the other image.
Yeah, here, this is the one. So there's two slits. Before you turn on the magnetic field, you see one line, and then you turn on the magnetic field and you see the split. And this is just an oven. And this oven, and this is everything is a vacuum.
Okay, but so they still end up being shot.
How?
Yeah, they have to leave the oven.
But why would, I don't know, maybe I don't know what causes them to move. Like, I think they're just diffusing. This is just diffusion.
But they don't diffuse without the magnetic field. They go in a...
I mean,
Yeah.
they're diffusing. I mean, there's no diffusion because it's a vacuum, but because of entropy, this is silver vapor. The silver vapor wants to go everywhere. So they just go everywhere. Why would the silver vapor stay here forever? Because of entropy, it just leaves. It just travels.
Yeah, okay, yeah, that's how they did it. But now, problem with that is that it is traveling.
Dr. Alpha, how are you?
It is
Terrific.
traveling, so this is a little bit different.
Dr. Alpha, we're doing quantum mechanics on my StreamYard. Do you want to join? Do you know quantum mechanics?
Not very well.
Do you want me to call you back when I'm done with this session with Mr. Chinas?
That's not going to take very long.
Just watch for now. I'm not going to be able to be on for that long.
Wait, like if I call you back in like 15 minutes, are you going to be dead?
Probably not, no.
I'll call you back in like 15 minutes. We can talk.
All right, cool.
I'll call you back. Thanks. All right, let's continue. So we were... Where were we? Oh, here? Yeah, okay. So that's my theory of what happened here. That it's a vacuum and they're just burning. It's a furnace. They're just warming up pure silver. It's just pure silver being warmed up. So the silver evaporates. It doesn't burn, it just evaporates. And it floats, it bounces all around because of why do I mean because vapor bounces around, because it has energy. That's just I mean I think they I don't want to get into the theory, but anyway, it becomes vapor. It becomes a
Okay,
gas.
let's imagine this without the magnetic field. So you're saying that
It's just gas. It's
you're
silver
saying
gas.
that the electron go without the magnetic field will just go around the atom. Is that what you're saying?
Without the magnetic field, there is this gas just ended up as one line over here.
Okay, fine, but I'm asking you about how the atom behaves.
What do
right?
you mean?
Like without the magnetic field, you're saying that it would just
Without
go
the
around.
magnetic field, you're right. It was basically a beam, but that's because of the energy. This
No,
probably
I'm talking about each silver atom.
Yeah.
Without
silver-
wait. Without the magnetic field, the electron would just go around the atom. Is
the
that what you're
electron
saying?
goes around the atom. We're talking about the 49th electron on the
Yes.
last orbit, on the last shell, where it's alone. All the other electrons, there's 48. There's
They're
up and
pairs,
down.
and that's
They
fine.
all counterbalance each other. So there's zero magnetic moment from all the other electrons. So only one electron at the end of the day gives a single atomic silver atom.
It's magnetic moment.
It's
Okay,
magnetic moment.
fine, but that you're saying that electron without any magnetic field would just be going around the atom.
Of course, it waves
Okay,
around the
fine.
atom. That's Bohr's model.
But that's the thing. Like once you subject it to a magnetic field, then now it has a force. Then now there's a force that is keeping it from going around the atom, so it becomes a pendulum.
No.
Is that what you're saying? Because
No. The electron. Look, the atomic. The silver atom. All silver atoms look identical.
Yes.
They have 49 protons, 49 neutrons in the nucleus that are organized identically, and they have 49 electrons in different I don't know how many, 10 shells or 15 shells that are organized identically. So any two silver atoms look identical. If I could magnify as two silver atoms, you would not be able to tell the difference between any two silver atoms, except for the magnetic moment, the angular momentum, where it is pointing. Right? One silver atom could be pointing up, another could be pointing to the right, another forward, another down, another in this direction. That it could be pointing the angular momentum due to.
Okay, but the angular momentum is just a vector that points to according to the right-hand rule.
Yes.
But okay, fine. But what I'm saying is, so the electron is rotating, right?
It's orbiting. It's waving.
Orbit.
Yes.
So its orbit will. So you're saying that its orbit will then start wobbling, right?
The orbit. Look, if you're let's say it's pointing to the right, and you're subjecting it to a north-south. So it wants to, let's say it wants to point, let's say it's pointing, let me draw this. We're gonna need to draw it. So let me share.
And you're saying that the spin gets accelerated, like it's like the orbit gets accelerated, and then it
No,
just
no,
kind of becomes
no,
like a pendulum.
no. I'm
No?
not. I don't think. I don't think so. Let me draw it. I don't know what you mean. So look. So here is the nucleus. Here is the final electron, the valence. It's called the valence electron.
Yes. Okay, fine. Well, what happens according to you to that?
Yeah. I'm just saying. Let's say it's pointing a little bit to the left, right? It's pointing a little bit to the left. Let's say, and then you're putting it through the magnetic field.
Yeah. So you're saying the same thing I'm saying.
And the magnetic field is perfectly up. So the magnetic field is perfectly up, and this is like a compass. So there is a force to rotate this thing clockwise. There is a tiny force to rotate. But once it starts rotating, when it reaches the center, it has angular momentum. It
Yes.
wants to
There
continue.
is one problem with that. Let me tell you what
No,
the problem with that
it
is.
processes. No. But the point is,
Let me
this
tell you
will.
what the problem with that is.
No. But before that, it will process. It will precess.
I have understood that, but let me tell you what the problem with that is. The problem with that is that precession changes as the electron approaches the magnet.
Okay.
So that's a problem.
What do you mean? I don't understand. No.
Well, the electron, the atom of the silver atom is attracted to the magnet, right? Yes, it has to.
Okay, let's say it is fine.
No, it definitely is. So that will change things because then the force will become stronger.
The point is,
it's not a pendulum because the force of gravity never becomes stronger. Like the pendulum keeps going forever with the same, with the same wavelength. Let's call it that way, because the force of gravity never becomes stronger. If the force of gravity would become stronger, then the wavelength or the precession of the pendulum would become, the angle would diminish.
I don't understand. Look.
So as imagine you have a pendulum and the force. Let me explain. If you don't understand, let me explain. Imagine you have a pendulum, but the force of gravity, as the pendulum goes, keeps going up. What would happen to that pendulum?
What do you mean the force keeps going up? I don't understand.
The acceleration of look, G keeps going up.
I don't understand.
Look, you have mg. G keeps going up.
Why? Why would G
or
keep
down if you're seeing it on the negative?
Why would it go up or down?
No, I'm telling you to imagine that situation. What would happen? You kind of, your brain is kind of blocked. Just clear your mind. Imagine the situation.
Well, if it isn't Mr. Slave.
Wait, hold on.
Not
Gamma.
Yep.
Gamma, do you want to do some stuff later? Want to write papers and do stuff?
Are you busy right now?
I'm with Chinas. He's my OG partner that I started this theory with him.
Who?
Chinas. Mr. Chinas. I'm with Mr. Chinas.
Is he related to Gerp? Or
No, he's not related to anything. He's unrelatable.
Is he in the server?
No, he is on the StreamYard. I usually work on the StreamYard so we can roam the internets together. So are you gonna be available later?
Yes, yes.
So we can do. I was thinking. I told you. If you want to do math, we could do Gauss's theorem. We can derive.
Yeah.
You would love that. If you want to do math, yeah, that we could do that. We could do a lot of stuff. We could do Planck, Einstein, de Broglie, Bohr, Schrodinger with the ether. We could do whatever you want. Math, pure math, whatever you want.
Gauss sounds pretty close. We should do that.
Gauss is perfect. Okay, so I'll come pick you up later.
Okay.
I'll see you, buddy.
Bye.
Bye. Okay, Mr. Chinas, let's continue. What do you say? Okay, so yeah, I don't know what you're saying. I don't know what you're saying.
Like imagine that G would be going up in every swing of the pendulum.
But
The G
but
would be
G
going up.
but you don't have to imagine it goes up.
No, but I'm telling you to imagine it.
No, but it does go up, right? The
No, it
vector
generally
the,
doesn't go up in a pendulum.
the
Like,
vector goes up and down.
no, not the vector. This is the value of G, not.
No, but mg, the force is zero at the center, and the force grows to the right, linearly in
No, the
relationship.
force is constant.
No,
The force is
No.
constant. The velocity is not. The force
No,
is
no,
always
no.
pointing down.
No, the force is equal to mg theta.
Mg theta.
Yeah, mg tangent theta, which is mg sine theta, which is basically mg theta. So when theta is 0, then the force is 0.
Oh no! That's the effective force. That's something else.
What?
That's the
This is the
effective
force.
on a
This is the
certain
force.
No, that's the effective force in a certain direction. That splits the x and the y. So that's different. No, I'm telling you like the total. It's like that has to do like that is counting also on like how the pendulum is like what the how can I say, like what the equilibrium of the forces is, because in the in the lowest position of the pendulum, then it will be compensated by the force that the pendulum is exerting. No, I'm telling you, look, just imagine gravity would become stronger over time. Just imagine that.
Why are you making it? Why are you making? But it's identical to a pendulum. I mean, I don't understand why we're having this discussion.
Look,
where? Explain to me.
Imagine
Explain to me where are you taking this conversation? So I have a feeling where are you taking the conversation?
I'm going to explain to you why we see a split, even though what you're saying here is true. But you really just have to imagine
we see a split. Wait, but I mean, do you understand the precession? Do you understand this?
I understand the precession. But
how do you get rid? Just answer. Wait 1 second. Let me ask questions. Hold on. Can you explain to me how you get rid of the precession? How do you get rid of the precession?
Don't get rid of the precession.
So, if you don't get rid of the precession, then you should.
But we're going to make the precession smaller.
So you're getting rid of the precession. What do you mean you're going to make it smaller?
Totally, but it becomes smaller.
Then you're getting rid of the precession.
Okay, fine. If you want to.
How? How? You have conservation.
That's what I'm trying to explain to
Wait
you.
a minute. Let me ask questions. Hold on. You have conservation of energy. How do you get rid of the precession?
You don't have conservation of energy because your force is changing.
Force is changing.
Yes, as the atom gets closer to the magnet, it gets the force on the thing becomes stronger. So you don't have conservation of energy. That's the problem. So you cannot do this.
Okay, so the force is equal to the negative divergence of the potential energy.
Okay. No, they don't need maths for this.
No.
It gets closer to the magnet.
No, the force is equal to the moment, or the moment is equal. No, I'm trying to think
Yeah, it's
through
something like
mathematics.
that. I don't remember what the exact formula is.
So it's like related to the B in the Z direction, dz, something like that. Let me look it up. Let me look it up. So you're saying that you don't have a precession. You
No, your precession will become smaller.
drip noob. Drip noob. I don't know. We have drip noob. Okay, let me see if we have here the
Incidences
equations of
that
the
led to the success.
precession. If not, we'll go to the previous video to see the equations.
It still doesn't matter.
What do you mean?
No, we don't need that.
What do you mean?
Like the precession is going to become smaller and smaller, so they will align accordingly.
Here it is. The force.
Okay, fine. Whatever.
So the potential energy. Why is it still running?
Alright, so look, the distance is going to become smaller. It doesn't matter. Okay, so the B0 is there's a divergence on the field. Okay, not really. That's not really true. Well, also, that's not really how this works.
You're saying that because the force is not constant, therefore you're getting rid of the precession?
Yeah, it becomes smaller. A lot smaller.
Why?
As it gets closer. Yeah, because you're constantly like pushing it. So you'd have to assume that the atoms don't move closer to the magnets, which is really strange.
No, of course they move closer. I mean, this is a
They move closer to
force.
the magnets. They move closer to the magnets.
This is of course they move. That's why some of them go up, some of them go down. You're saying that you're able to basically pretend as if they're losing energy because the
Not that
energy.
they're losing energy.
No, it's like the energy changes. So
no, the energy doesn't. No, they're not losing energy.
There's no. You're getting rid. You're destroying the harmonic motion.
No.
Yeah. You're.
Faster.
It's fine. You're not. You don't. You're destroying the eigenvalue. You're destroying the resonance. Like there's no resonance. You're saying that because the force keeps changing, the system is not resonant. So by the time they leave the magnet, they're no longer resonating. They're stable wherever they are. You basically damp because.
What do you mean they're no longer resonating?
If the force was constant, if the force did not change, then you would get a precession. You would get a forever precession.
Okay, but the force changes.
Because the force changes, it doesn't enter. It cannot enter any precession. Like whatever precession it starts entering, you're continuously ruining the resonance. You're not letting it resonate.
Continuously ruining the resonance. That's how it works.
And that's why some of them go up and some of them go down as if they lost energy. Basically, they did lose
energy.
They did lose energy. This is
faster.
No. They did lose energy. Of course, they lost energy. They
Okay,
gave
maybe they lost a bit of energy. Fine, whatever.
they gave some of the energy back to the system. That's what happened here.
Yeah, they have to.
Yeah, of course. There's loss of energy. This is loss of energy. They communicated back into the main magnet. They gave the main magnet back energy. Some of the energy that they received, they gave
with
back.
the magnet, they gave the environment.
They gave probably the magnet.
No,
No.
not necessarily the magnet.
It has to
Whatever's
be.
around them.
No. They gave it back to the main magnet.
Nah. Okay, whatever. It doesn't matter.
This is fascinating. So I was thinking. So this is very good. This is amazing. This answers the question how they lost energy. This is what Einstein couldn't figure out.
Okay.
Einstein could not figure it out. I never heard anyone mention this. You need your name. Your name has to be very famous. They should call you Mr. Chinas.
Yes, that's
The great Mr. Chinas. So
Venus means something unspecified.
Mr. Chinas. No, Chinas means Chinese. You didn't know that, Mr. Chinas?
Chinas. I know, but that's not how we write it in
right, Mr. Chinas. I say Mr. Chinas. Anyway, Mr. Chinas, this is very interesting. I'm gonna have to test this theory. This is good because I was thinking about I was thinking about many things, but this is really simple. This is so simple. This makes sense.
It's not complicated. They have to align in some way, and I suspect they do align actually quite fast because that other experiment, the Abramov bomb experiment, that one.
No.
I've shown you that experiment.
Yeah, I never looked into it.
I never get the name of the first guy right. I think it's Abramov. Yeah, the Russians have some really no, it's Aharonov. Damn son.
Aronov is a name from the Bible. There's Aaron or something from the Bible.
It's like Aaron, but then he has the Ov, so he's Russian Aaron.
Yeah, the son of Aaron.
He's like a Russian Jew.
Yeah.
Probably.
So the potential energy.
Yeah, you should look into that. I'll put on the StreamYard. Maybe I'll put on your shot.
It doesn't matter. You gave the answer. This is good. This destroys. This completely annihilates the precession. I don't need Aaron. I don't need Aaron. I can do without Aaron.
Yeah, you can do it without him, but it's still interesting to look into because like the electrons really align spin very 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 fast, and it's probably like a similar effect. It is even like the interesting thing about this effect is that this is even in a zone where you can't detect any magnetic field. So let alone a zone where you have like very very detectable magnetic field.
Okay, this guy's a PhD. Let me.
Tapioca
Weasel. He's an actual quantum researcher.
Oh, interesting.
Yeah. So what I'm going to tell him, I'm going to take a snapshot of this screen. I'm going to tell him what you said.
Okay.
So I'm going to tell him that the atom. So The magnetic.
The precession becomes smaller or something.
I would just say the magnetic interaction between the atom and the main magnetic field is obviously, I mean, who's here?
It's me. The same guy you talked to before. My
Who?
God. What's up, man?
Who's Nidal?
You know me. You know me very well.
No, I don't. How would I know you?
We talked about Iran.
We talked about Iran?
Yeah,
When?
in your live stream.
When? Like,
I don't know when exactly, but to be more specific, it's been 3 months or 2, maybe.
are you Iranian?
No, fuck no. If I were Iranian, I wouldn't follow its regime. Its nowadays regime.
Are you Egyptian?
No, I'm not.
I don't remember you. But I'm in the middle
I
of...
don't want to disclose about my area, about the information about where I locate.
Okay, let me make you. I'll make you. We're friends. Let me send you
Yeah,
hi.
you're already my friend.
Yes, but I'm right now. I'm writing a very important letter to a very important person. Let me get back to you. I'll invite you back in a couple of minutes, or maybe in an hour. Are you? Or
It's getting late in my country now.
What?
It would be inconvenience for you to come here and you don't see me.
Okay.
I'm not a perpetual, but I need to go to sleep. That's why.
So
I came here to salute you and go back to sleep. Yeah.
Thank you for
You have a
saluting.
salute?
I salute you back. I don't know why you saluting me. I salute everybody.
Oh.
Anyway, I'll
So
be. I'll stay in touch with
Sorry.
you. I'll stay in touch with you. I really need to finish this letter. It's very important.
I'm sorry.
No, it's not a
for the-
problem. And
I'm sorry for the interruption, but I came here so that you won't feel lonely.
I'm not lonely. Thank you so much. But even if when I'm lonely, I'm very productive. So either way, thank you so much.
Thank you.
All right,
That's fine.
Thank you. I'll see you around.
I owe you that.
Yeah.
Goodbye. God
Goodbye.
bless you.
Thank you. Bye bye. So the magnetic interaction between the atom and the main magnetic field is obviously what do you call it? Non-uniform. This has the effect of destroying any self-resonance.
You said destroying, not destroying, but
precessions. Of destroying any self-resonance precession.
Yeah, that's basically it.
This has the effect of. This is a similar effect. This has a similar effect to loss of energy.
I don't think you need that part.
It's critical. This is what Einstein said is missing, which is what was missing according to Einstein said he doesn't know how the atoms could lose energy. That's what he said. Which is what was missing according to unless Einstein already thought about it. Unless Einstein already included this in the calculations. Maybe he did.
Okay, and if this guy is a PhD in physics, maybe he knows that.
No, nobody knows these things.
Oh.
I talked to him. I know what he knows. I mean, you have to live this experiment. You know, you have to live it in order to be able to tell you or teach it, or he doesn't know enough. He knows a little bit, which is what was missing according to Einstein. Einstein said that an atom needs 100 years in order to lose the energy of the precession. The atoms are basically returning, right? They're receiving energy, but they are moving the main magnets. They're giving back the energy to the main magnets. Whatever energy they receive, they're giving back. The atoms are basically giving back.
They're interacting, basically.
Yeah, but they're giving it back in terms of heat. Somehow the energy is returned. The atoms are basically giving back the energy they received in order to align to the main magnets. So the atoms are basically giving back the energy that they received in order to align with the main magnet. So the atoms are basically giving back the energy to the main magnets. This explains the splitting of the beam in a classical way. In a classical way. I don't know. Anything else?
That's fine. Let's see if he.
The Stern. Let me just go. The Stern-Gerlach experiment is completely classical. We don't.
Experiment is like the stupidest experiment ever.
Yeah, we don't need any woo complex math, Dirac notations. Wave collapse, parallel universe. The universe conspires explanation. What do you think? The magnetic interaction between the atom and the main magnetic field is obviously non-uniform. This has the effect of destroying any self-resonance precession. This has a similar effect to loss of energy, which is what was missing according to Einstein. Einstein said that an atom needs 100 years in order to lose the energy of the precession. The atoms are basically giving back the energy that they received in order to align with the main magnets to the main magnets. This explains the splitting of the beam in classical way. The Stern-Gerlach experiment is completely classical. We don't need any woo-woo complex math, Dirac notation, wave collapse, parallel universe. The universe conspires explanation. What do you think?
I mean, they don't even need to write that much, but
of course not. I don't need to say anything. I mean, this is obviously complete. The whole thing is so nonsensical. But let me just. how do you edit message? I just want to make sure that the magnetic interaction between the atom and the main magnetic field is obviously non-uniform. This has the effect of destroying any destroying any self-resonance precession eigenvalue pendulum. I mean, yeah, whatever. Undulation. Is that a word, undulation? No? So what is the word? Angulation?
Yeah.
Undulation with a U. Okay. Undulation. This the loss of energy, which is what was missing according to Einstein said that 100 years, the atoms are basically giving back the energy that they received in order to align with the main magnets. Right? Work was done, but work is done if you're able to lose to right. This system conserves energy. Right, a pendulum conserves energy. This system does not conserve energy. This is not conserve energy.
No, there's a differential in the force.
This system does not conserve energy. I mean, it could. No, of course it conserves energy. There's between the magnets and the atom, the energy is conserved. The point is, whatever energy
is that the components of the system don't.
Look, the point is the force. Right? It's not just the force. This force would cause precession. The point is that this force changes in such a way that it destroys the precession. It's like it's many precessions, so they're canceling each other out. You can't have many precessions. They're all working against each other. Like it's trying to enter one precession, but then it's a different force and a different force. It's always a different force.
Mm-hmm. Yeah.
It's just always there. It's growing stronger, and it's growing stronger linearly.
Yeah, there should be some criticism like this too.
But the motion is not linear because it's accelerating. So it's really very complex.
Yeah,
because no one everybody only looks at the z vector motion. Everybody just looks at the moment and stops. I've seen everyone discuss this. Everyone looks at the moment, the magnetic moment, and that's where they stop the discussion. They don't think about the fact that wait, this thing starts moving. This is a moving system. This thing starts moving. It moves. This thing moves. What are we crazy, or did we forget to take our crazy pills?
I think humanity forgot in general.
This thing moves. This thing it moves. It moves up or down. By moving up and down, so everything changes. It's moving. If it's moving, then this force keeps changing. It's not a constant force. The force keeps changing relative to the motion. But the motion, this is like a complex system. This is this is an entangled. No. Hey, listen. This is a classically entangled system. This is not a simple differential equation, because
no, it's not. It's like a phase space.
No, this is MA. You have to say MA, right? F equals MA, but Z has to do, right? There is this is vector z. Z is not even mentioned here. Z is not even mentioned, but they only care about. They say it changes linearly, which I don't even know if it's true. This is just an assumption that this changes. This doesn't even change. This is not changing linearly. This is this is very a complicated function. So I don't even know how it changes. Nothing can interact with you cannot get an eigenvalue out of this system. So this system behaves like a lossy system, that loses energy. So of course it loses the magnetic moment. There's no way it's going to preserve a magnetic moment. There's no way it's not going to continue precessing. It's not going to enter some eigenvalue of precession. It can't. As soon as it does, it gets ruined. It keeps ruining and ruining and ruining and ruining and ruining the precession. So it just aligns. Of course it just aligns. This thing cannot precess. For precession, you need some constant force, but the force is not constant.
Yeah, that's it.
No, but they would say, look, so as it's precessing one way, you're pushing it with a different force. But then when it overshoots, you're stopping it with a different force. It's like a spiral. This is okay. I have an intuition.
It will work like a spiral to spiraling into the inside.
So here is the original. Let's say it starts like this. This is mu, and this is b, right? So this magnet wants to align. So there is a force to align, but it's also moving up. It's both moving up and aligning. So this force is actually, right, as it gets to zero, right, the force goes to zero, sure, but it doesn't go down. It actually increases. And usually we say that it's relative to the omega, but that's not even true, because this is assuming small omega, then you can say it's omega, but otherwise it has to be the tangent of omega, which makes it a very complicated by itself. Anyway, fine. But as it gets to zero, on the other side, it's not the identical force. It's not the same force, because now it's already up here. Up here, it's a much bigger force.
Yeah.
So it's not precessing. It's being stopped and stopped and stopped and stopped and stopped and stopped. So it
aligns.
So it aligns towards the center. It's always being stopped. It's not that you go to the playground and you push and it goes and you push again. No. You're pushing and you're pushing and you're pushing. So of course it's not going to go anywhere. You're always pushing. But fine, it overshoots. The first time it overshoots, but then the next time the force is stronger, and then it overshoots, but the force is stronger. It's always overshooting, but the aligning force is always stronger. It's always stronger, always stronger. Looks to me. So the question is, is this unstable or is this stable? So I don't know.
Stable. In the end, it stabilizes.
I don't know. So the question is, well, it depends on the BDZ. The BDZ, depends on how it changes. I don't know. It depends on that.
Yeah, I think it might change. Say that it doesn't change, but it does.
Look, it could be that this is. It could be that this is not even strong enough. It could be that this is not even strong enough to align it even, to shoot it, to overshoot once. So maybe it didn't even overshoot one. I don't know. I just don't know. So in the beginning, when they fired they fired the beam, so in the beginning they got this, and then they increased the magnet, and then they got the split. The split is this. So in the beginning, they got one bump in the center, which means that it wasn't splitting. So they needed to add more magnetic field to make it split.
At the
You
beginning,
understand this?
In the first experiment,
In the first is 0. In the first it's 0. Then this is B1,
interesting.
and this is B2. So B1 it didn't split. B2 it did split.
Wait, what did it 1B1?
B1 is low level magnetic field. B2 is stronger. What?
Well, that makes sense. Like they didn't, but that is interesting.
Nobody talks about.
There's finally one interesting thing about this experiment.
Nobody talks about
that gives us a clue just how much magnetic field we need to have that effect. But they
Hold
got
on.
like a bump.
Wait 1 second. Wait 1 second. Nobody talks about the shape of the magnet. It's like nobody cares about the shape of the magnet. Like the shape of the magnet gives you dB/dZ. Nobody talks about that. Like different shapes might give you different results.
For sure. But
the question is.
In B1, what do you mean they got one bump? Like they got like a.
I mean, right?
Like
so
a parabola.
Look, at the end, in the beginning, it looks like this, right? At the end, it looks like this.
Oh, they got like. Yeah.
So if you take a cross section, these are 2 bumps. If you take a cross section, it's 1 bump.
Oh, I see. Yeah, I see. Okay, so they had to have a strong enough magnetic field to cause the split. Yeah, I mean that does make sense.
So the magnetic field was such that it aligned it.
More to do with like how the other instruments are.
Look, the fact that the magnetic field changes, it starts giving us a loss of energy function. A function that looks like it's losing energy. It looks like it's losing, the system, or at least the atom looks like it's losing energy. It can look like. It can look like. So we don't need to throw to the garbage causality. These people are such idiots.
Causality to the garbage.
But these people, they're like, it's like a child that is waiting to grab a cookie. It's like the child is gonna grab the cookie. It's like a kitten looking to catch the mouse. It's like the kitten is gonna catch the mouse, or I don't know. Like these people, they want to get rid of causality, like you want to go to sleep. It's like, like they want to. They hate causality. They hate these people. These are magical. These are mystics. These are mystical people. They're mystics. They hate rationality. They just hate it. Or they're idiots. Or both. I don't know. It's like given half a chance to drop causality. Oh, no more causality. No more causality. Yeah, we don't need causality. We don't need causality. We don't need a mechanical universe. Yeah, we're fine. Everything is fine. Yeah, there's no laws, no logic, multiverse.
Yeah, that is the problem, because if you drop those things, you're kind of dismissing your entire theory, because
Of
then
course. It's
like
like,
if you don't have like simple principles of logic, then your mathematics doesn't mean anything. You
of
cannot
course. Like
interpret
these people, they go to the bank and the bank tells them, "Yeah, all your money's gone." They say, "Why is the money gone?" They say, "What do you mean? You don't care about causality. Why are you asking? Why are you asking? Obviously, you do care about causality. So stop the nonsense. Stop the nonsense already." Oh my god, I can't stand these people. And there's no, but look, there's no one to talk to. And when you talk to people, they start asking you, "Are you a mathematician? Why should? Do you have a PhD? Where did you go to school? What's your qualification?" Like,
Look,
are you listening?
even if you add that, it still wouldn't work, because they would say that the
I
majority of
know. Yeah, they
learning
still they keep.
is
Yeah, I could literally be a professor. I could be the head of the department of physics at MIT, and they would say you're a conspiracy theorist and you're a flat
Yeah, like
earther.
I remember when the thing that stopped the world economy came, and and I was like interpreting the statistics and telling people, no, there's not that much to worry about, like this is waning and stuff. And people would be like, well, are you a virologist or something like that? So like, look, biologists don't necessarily know how to interpret data. Like, oh, but are you an expert in statistics? And, yeah, I have a master's degree in AI, so yeah, this is very easy. And they would be like, well, but it's AI, it's not it's not
Yeah,
biology, and I was like, okay,
yeah,
well,
and
these
and
people
even
that biologists don't know.
no, but even if you had a PhD in virology, then you're a conspiracy. It doesn't matter.
Yeah.
There's no look. You cannot get away with these people. Nothing is gonna ever end. They want to live in a magical universe. And you're not gonna stop them.
Yeah, I mean, it's a weird thing.
Okay, I'm gonna write this up as a
Yeah,
paper. This is a paper.
I know I'm starting to like wonder. Have you ever seen like probably the stupidest thing in the entirety of like what's accepted by the mainstream? Which it's related to this. Like it's trying to get rid of logic, which is even better than trying to get rid of causality. So it's like, have you ever seen like Gödel's theorem?
Gödel's theorem.
Gödel.
Gödel. They call him Gödel. It's O with two dots.
Yeah,
It's Gödel.
it's like
Gödel.
the dumbest thing in the world, and it's accepted. Have you ever seen that?
I've heard. I mean, I've heard people. I've heard of it. I have my own Gödel's. His what is his theorem? That is incompleteness. Incompleteness
Yeah,
theorem.
he concluded that a system that's consistent cannot be complete. That was his conclusion. But
I would say that
the way he did it, like I'll tell you the way he did it, and you're gonna love really a lot to this. The way he did that is he made a circular definition. Like he made the definition that was G is there is no proof for G, and then he couldn't find a way to refer to a circular definition using something outside the circular definition. And so he said that logic is not complete. Do you understand?
no.
Like, okay, so he made a circular definition, which is by definition something that you can't refer to just by referring to some other proposition that is outside your definition. That's why a circular definition is invalid, because you cannot you're not referring to something else, therefore you're not defining anything in relation to anything else. So he did that, and because he did that, he concluded that logic could not explain his circular definition, and so according to him, he proved that a logical system cannot be complete.
I don't. I mean, I agree that no system can be complete.
Yeah,
No
but that's
system.
not what he's saying. He's saying that because a logical system, because you can't have anything because he made a circular definition again, which is by definition something you can't.
But every system, but every system,
cannot refer
every
to.
system is self-referential.
I mean, it's not like every system is self-referential. That's not really how it works. It's like every system in every system of definitions, the definitions have to work in relation to each other. That's the correct way of explaining it. Like it's just a way, like a system of definitions, just a way to have something, to have like a logic to the system, right? So you can
I would say
of the system means something in relation
every
to each other.
every system must have axioms. You cannot have a system without axioms.
Yes, and everything in the system relates to those axioms.
So, but yeah, I don't fine, but because every system must stand on axioms, therefore every system must be incomplete because these axioms are incomplete. An axiom is a lie. An axiom is something that we pretend to be true. We didn't prove it. We just
not
pretend.
necessarily. Like you can have axioms that have to be true.
No, then that's
you
not
can
an
have
axiom.
axioms that have to be true. That's like
An axiom. An axiom is a ground. No, it doesn't matter. It doesn't matter. You must have at one point. At one point, you must have an axiom that you just define to be true or assume to be true, even though you didn't.
Your axiom, your ultimate axiom is that A equals A. Like it's just a concept of equality. Like ultimately, your axioms are just concepts.
But A equals A is an assertion, just like every other assertion.
Yeah, axiom.
If you didn't prove it, you either prove it or it's an axiom. So
it's not really like that. Like A equals A is by definition.
That's fine, but it's an assertion. If I ask you, what's the proof that A equals A?
But no, it's an
if I
assertion
ask
that
you,
it's tautological. No, but
but
wait,
if I ask,
no, but wait, it's an assertion, but it's a tautological assertion. So it proves itself.
No, what's there's no what's the proof? Okay, how do you know A equals A?
Because it's a tautological assertion.
I don't know. What's the proof? You have to give me proof, or it's an axiom.
I don't have to give you a proof for a tautological assertion. No, you don't.
Look, how do you know A equals? How do you know A?
Wait a minute. You should read the work of Chris Lagan, which is the man with the highest IQ in the world. He talks about this sort of stuff. If you ever, it's okay to do self-reference and all of that if your self-referencing is tautological. And it proves itself essentially. You there?
I'm here. Okay, it doesn't matter. You want to go to sleep?
No, let's just finish the conversation. See if you understood this. But that's not the assertion of Gödel, right? You're giving me giving me very logical arguments.
Okay.
What Gödel actually did is he made a circular definition, i.e., a definition that's invalid, a definition that is like, I don't know. Imagine I'm referring to you and I say, Mr. Slave is Mr. Slave streaming. That doesn't make sense, right?
Mm-hmm.
You cannot make sense of this.
Right, you cannot make sense of it.
That's a self-referential definition. Like the definition itself is not the system; it's the definition itself is self-referential.
Okay.
That's invalid.
Okay.
Like you cannot do this because it's like an infinite loop. Like
I cannot understand what it means. Sure, and I agree. Okay.
And what Gödel did is he did that, and then he created a bunch of like Gödel numbers, which is basically like a different way of expressing logic, but in the end it's equivalent to like regular discursive logic. And then he said that he could not this circular definition that he made he could not obtain it by anything else within the system of logic. But that's normal because if you have that's the definition of like it must be true. Like that's the definition of circular definition. A circular definition is not definable within a system.
No,
Because
I don't know. I don't know what you mean.
yeah, because like
I
if I
understand.
say Mr. Slave is Mr. Slave streaming,
Yes, that
and
I
I have
got. Right?
and imagine like I have a series of like names of people, right?
Yes.
And those people, I define all those people in relation to each other. Like, okay, so Anna is Bob's cousin or something like that.
Okay. Mm-hmm.
And when I reach Mr. Slave, I say Mr. Slave is Mr. Slave's brother or something. Like, of course, I cannot go and look for something else within the system to like know what Mr. Slave is in relation to the other ones. I cannot do that. It's impossible, and it's impossible by definition. Like it's necessarily impossible. But and
say
there's
that.
nothing to conclude about that. The only thing I have to conclude about that is that
Wait.
I have defined Mr. Slave wrong. Like
Wait.
that's
I don't understand. You said okay. You took a bunch of names of people and you said Anna is Bob's sister, and when you get to
something like
Mr.
that.
Slave,
You
when you
say
get
Mr. Slave is Mr. Slave's friend or something. Like there's nothing. Like I cannot do anything with this in relation to the rest of the system.
I cannot understand it. I just cannot understand. Right? It's again a self-referential.
Yes, that's why it's invalid. Like that
Okay.
definition is invalid. It's not valid.
Okay.
It doesn't fit the rest of the system.
I
But
I don't know what it has to do with the rest of the system. I just cannot understand that statement.
yes, the
A
statement is
self-referential.
invalid. That's my point. You cannot understand it because it's invalid.
So what is the proof? I don't understand the proof.
No, like there's nothing to prove. The thing is, this is what Gödel did. That's what I'm trying to
But
say.
he has a proof that in
No, he
every
doesn't have
system
a proof. Like his proof is completely
he
wrong.
has a proof that in every system
No, he doesn't.
there are
Proof.
some
Like
no.
that's what
He
I'm
said
trying to
no.
say.
His theorem is that in every system there must be some true statements that can never be proved. That his and he
No, it
proved
doesn't
that.
prove that at all. Like you
And
should
from
check
what
it.
I
It
understand, he
doesn't prove
did.
it at all.
I saw Veritasium on Gödel's
Yes,
theorem.
I saw Veritasium, and Veritasium made like a completely wrong.
Oh, he did.
Yeah,
he usually doesn't get.
that
Okay, I don't
video of
care.
Veritasium makes no sense whatsoever.
Okay, I don't want to waste my time. Look, I'm
It,
gonna write.
no, it
It
didn't
doesn't matter.
actually prove it.
It
He
doesn't
made like
matter.
a he made
It
like a
doesn't.
conjecture based on a
It do,
circular definition
It
that
doesn't.
that was a true statement, and that true statement not be proven within the system. But the problem
Okay.
is
No,
suppose
no.
no,
Stop.
let me finish. The
Stop.
problem is
No.
the true
Oh.
statement is not a true statement.
Okay.
So
Stop.
he
Stop.
didn't
Stop.
prove
I
it.
don't care.
Okay,
I
fine.
don't care. I don't care. Look, we have things to do. This is. We'll get to Gödel's theorem if we ever decide that he's wrong. We'll get to him. But for now, we need to deal with the quantum mechanical multiverse. Cats and dogs are alive and dead, and the rest of the nonsense. We have to
Yes,
get.
but
We
you
have.
have to understand that this is all the same problem, right? It's
Oh,
like
you're
people
saying.
trying to get of logic and causality. You do understand that.
Okay, we'll get to logic. We'll talk about logic. Right now, I want to write this up. I want to write a paper about this. This is too important. But I need. I need to get an answer from Tapioca first.
Yeah.
Let me. I didn't send. Let me.
Okay.
Let me send the update.
Is what? Is Canadian or something?
I don't remember. Maybe he told me. I think he's American. I think he's American. I think he works in Stanford, in the Stanford lab,
Oh, okay.
in the quantum physics lab. Yeah. He's a top-notch guy. Top-notch.
Okay.
So, okay, go to sleep.
Okay.
I'll talk to you tomorrow.
I've already slept. No, just joking.
Oh, okay. I'll see you later.
See you.
See you. Bye.
Bye.
Bye. Okay, what I want to do now is think I'm gonna go make myself a shake and then come back. Okay. So let me change the name. Stern-Gerlach experiment. Let's change the name of the stream. I mean, we did some of this, some of that. So we did theory of everything, quantum gravity, ether, quantum gravity, ether, theory of everything, quantum gravity, ether. That was topic 1. Topic 2 is Stern-Gerlach experiment. Resolution, possible resolution. Okay, that's it. Save. All right, we're gonna stop here and I'm gonna make myself a shake and come back. Bye.